MD. I think I actually had a whole hack MD just about this specific API shape. Where is it? Yeah, I have a whole hack on MD on how to. Okay. Yeah, let's talk about that right after this one. But yeah, it is possible. I identified, I think, 3 different APIs. I finally decided that this was the lesser evil of them. Again, TypeScript is just miserable when you're trying to design systems. Run pure queue as transition queue. Any newly created nodes are not part of the transition. That's fine. Where did I get to? When all prompts are resolved, merge back and run effects. It's the least more straightforward. We get to the point existing nodes can be merged. Takeaways. Okay. We only need to clone nodes that are notified during the transition since we discourage writes and computations, which I've actually added a warning to in Solid 2.0 right now. This should mainly be in transition or resume functions, firewalls, or in firewalls when draining the pure queue. Everything else can be created as normal. When cloning, we don't need to clone children or cleanups. These will be created when it runs and don't want to clean up the original. Since this is a variation on a single feature, even if it can be discrete parts, we only need one transition-specific node clone for an existing node. We have to be conscious of keeping independent graphs while still being able to notify from the main branch to the transition branch. This might take a little bit of fiddling with how we do the linking and lookup. So yeah, I actually solved all that, and I'll show that in the code in a few minutes. But this is the core idea of how you can do transitions in a signals-based library. It was funny when I first did concurrent in Solid 1.0. I remember people like very influential people in the React community basically saying it wasn't possible to do with signals, and I'm like, no, I've already did it. I did it like a year ago, and they're like, no, blah blah blah. It's not. Like literally just kept on repeating the same thing, like Paul Henschel from 3JS. Specifically, and it was like, no, I've remade your concurrent demo. It literally works. I showed it to you multiple times. People really had a heart disbelief that you could do this stuff without the VDOM. We already did in 1.0, but I think this is going to be better with this ability to isolate based on the reactive graph. We use the same technology, as I said, to figure out error boundaries and suspense. So why not use it here on transitions? Yeah, if you add an additional wrapper function, I don't know. MobX hasn't solved this to this day. There's a very, very long thread, and I just was like, if nobody in the MobX community have solved flow functions, I am not going to be the one that's figured it out. Right, like you can type generators, but can you type it so that it knows that anytime you yield a promise, you actually get the value? Like the reason is you do something. It's kind of weird what you do, because you basically what you're saying is, I want, because you don't want to go yield a wait. I don't think that's a little bit too clunky. You want to go yield this, but it might be like the code you might end up with might be like drop it down here for a second. The code you end up with might be something like this: yield. To do this is right. It was getting this to be not promise of this value, but the actual value of it. Yeah, no arrows for generators is annoying as hell too. Oh, it's yield star. What's yield star? Okay. Yeah. Oh, it's yield star. My bad. Whatever. You get. But yeah, getting this to be, where is, if you do this, like you will get the proper type, assuming that this is this. Anyways, that MobX has like literally a 3-year old, like 4-year ongoing thread without like hundreds of responses in it that no one's actually solved this problem adequately over the like last 5 years. I think there was a trick because Mob actually uses classes that they could build it into like the class types or something. But like from the pure function standpoint, there it all involved like adding functions just for the sake of TypeScript, which hurts me deeply. As I said, I also am hurt deeply that TypeScript impacts the shape of API design. TypeScript is, as I said, very, very annoying for designing APIs. Yeah, exactly. Like you pass into a function to get the function to get the types. It's doable. It's just again, if someone says you need to wrap something in a function for it to work with TypeScript, then yeah, I'm like seriously, because then now it's like, oh, is this a function that we also have to send out as a part of our library for type so that people can do this? It's just like, I know people are used to doing this in TypeScript, but and maybe I should be like, take that stance that TypeScript users are crazy. It's just really dumb when you hit issues like that. Anyway, right. Let's talk about. So I introduced a moment ago that what if um how do you deal with showing pending state for transitions, right? That's kind of like the next topic here. It's very relevant for optimistic updates, like for like actions, which React calls the actions like any async function passed to a transition. Solid, we had a special action wrapper, and I think Svelte kit ended up using the same approach Solid did with the action wrapper. Remix has those like exported functions, or sorry, React Router 7 version, whatever, has the exported 7 functions. But like, generally speaking, conceptually, there's a mutation part of this transition async part of the story. Both of these problems actually are kind of similar, and React actually might have come up with a really elegant solution to it. I was talking to Ricky, and he convinced me. So let's talk a bit about this, because when I first went into transitions, what I kind of wanted to do was like basically await transition and go like set pending, await transition, set pending false, like as a way of handling it. And then I was like, ooh, the await's too late after the fact. So then I was like, what if I make it a callback? So like when transition function, and then when transition done, callback function, then we can call it synchronously, like before the transition ends, right? Because there's this time period between when you've done all the pure calculations and you haven't applied the effects yet. It'd be really nice to be able to like do a few more updates in there and then apply the effects. If you do an await, it's going to be after the render, so it's too late. Right. So here, set pending true, transition, set tab B thing. That's my thinking. Right. And I think I was also really interested in Vue transition API. I thought, I don't know if people are familiar with the Vue transition API from the browser, like start Vue transition. Again, a different type of transition. But the idea here is you can do animations, and then when you call start Vue transition, it basically starts doing a snapshot of the current UI. This is a lot like the freeze the UI non-updating thing. And then when it's done making the snapshot, it calls your update function where you can apply your changes. And then when your changes are done, it will transition the UI from A to B. Now, great API shape on the surface. You're like, oh, this is great. But kind of awkward. Because I was like, okay, wouldn't it be cool if we could just like make transitions work into this automatically, right? Because First of all, start view transition is not synchronous. It's async. So if like here's a problem, and this people will do it today. They'll start view transition here somewhere, like out here when they do the action, when they press the button, when they go to click save. And then they will await the transition stuff inside the callback function. So it'll snapshot, and then it'll start the transition, call the callback function, realize the asynchronicity of our transition, and then when it's finished, it will do the transfer, which works. But it means that between you first clicking the button and this finishing, and there is a bit of a delay because it won't call this start transition right away, like because it's async, but it freezes the browser. So the whole time it takes for you to fetch your data to get to the next page, like or on the update, it froze the browser, the thing we didn't want it to do. You don't want this function to really be async, or if it's async, it should be like immediate micro queue. You don't want this to be waiting, because once it's done its snapshot and it calls this, it expects to be like to animate. The time between the initial call finishing and or basically the whole time it takes for this to finish, including the async time here, if your update callback freezes the browser. So you shouldn't be using view transitions that way. But it means that it's freaking awkward timing, because the ideal time to do this is to call start view transition right when you're done the pure queue, but before you run the effects, and then run the effects in here, except this is async. So you actually are in the middle of the framework's render process, and then they're like, oh yeah, we're going async now. And you're like, no, but I have to apply my stuff synchronously. So you'd be like, oh, maybe it's an I call you kind of situation where you give them the ability to call your effect renderer, whenever they finish their snapshot. It's weird. Now, there's ways around this. You can like maybe provide an API where you could pass in like a promise that you can basically pass into here. So like you do your render synchronously immediately, but when your render, yeah, I mean it's tricky timing wise, because this is async. You have to kind of await them taking the snapshot. Let me think here. Do you have to wait them taking the snapshot? No, they can take the snapshot immediately, but you have to make sure that you don't render your effects before they finish taking their snapshot. So yeah, you do have to kind of wait them taking the snapshot, right? So even if you could say like, look, you don't have to call my render function. I'll just call a promise, that I pass into you when I'm done rendering. This still can happen too late. So like, and Ricky pointed out too, when I talked to him, that sometimes for things like suspense, like fallbacks, you want to use view transition, which have nothing to do with transitions. So like this wasn't the right fit, but I definitely was looking into this, because in my head, I was like, oh, wouldn't it be cool if you could just call start view transition right here in the second function in between when the like pure part and all the async resolves. So you're not holding the page while the async resolves. And then right before you actually merge in the transition effects, do the view transition. It seems ideal. The problem again is because it's all async, it basically won't play nice with us. So we have to kind of come up with our own solutions there. But yeah, I realized that we can't just merge these things together. There's places you want to use view transitions that have nothing to do with transitions, like with suspense. And the fact that the start view transition is async is very painful for frameworks. They need the special case, which means you probably can't just hand this out to the end user to use the native APIs. You have to wrap it yourself, maybe in like a view transition component. I know, a little tangent, but I just kind of want to put that out there, that like these are the kind of considerations that go into designing these API shapes and stuff. And I was really hoping for like, oh, look, we just use the native stuff the way we want it to. Unfortunately, the native stuff is designed in such a way that is very awkward for UI frameworks, as usual. But again, it's a very difficult place to be to kind of figure this stuff out ahead of time, because someone has to propose it and then be very involved with trying it to kind of figure this out. And it makes sense why this would be async, because taking a snapshot probably does take some amount of time. Maybe not a huge amount of time, but it takes some amount of time. But can we guarantee, like, the snapshot happens before we render the DOM on the same synchronous task? I don't know. I maybe it does. Like, maybe the starting is enough, and the waiting is just when it finishes. Maybe this is worth like looking further into the spec. That being said, as I said, it doesn't apply for suspense, so I'm not going to worry too much about it. It doesn't belong as part of this API. We could look at having a specific, like, maybe like on, how we have on mount in Solid, like that it runs right at the while the effects are running on the after the render effects. Maybe there's like an on before render kind of cycle, and if this does work in a reasonable way, then we could just hook in to that life cycle and then kind of use our same scheduling queuing mechanism, so that like you can call this function when it's off screen, and then when it goes to like merge in suspense or transition, that's when it actually runs, because it's scheduled to run at that point in the life cycle when it actually mounts, so to speak, or renders on screen for the first time. So yeah, I think there's like potential here, but it doesn't make sense to bake it right into transition API. Okay. So it's worth noting that React has something called use optimistic, which is like ephemeral state. It handles all pending states around transitions, converting into an equivalent solid with something like this: create optimistic, false, true. So the way the React version works is you just set some pending state, and then at the end of the transition, it gets reset to their initial value, right? So instead of having, this before and after thing, you literally just go before, and then when the transition's done, it's over. It automatically resets the base value when the transition ends. You can also make the base value derived into immutable overrides. So yeah, in React, they have this thing where you can actually base it on like a list and then like merge the stuff in. And this is actually kind of interesting, because I was thinking, I'm like, what if you made this a reactive list and then pass that list in and then apply the stuff in? But since it's reactive, but what if it's immutable though, right? Every time you get a new to-do, you're cloning everything, right? What if we just made that mutable, right? What if secretly under the hood, only when you add this function, like here's a signal, here's the signal version, it just swaps a value, right? Set pending, set false, right? This is like a signal, right? It's very clearly setting value. But when you add the second function here that does the diff, what if you just made it a projection? What if this is derived mutable reactivity, like we've been working on the last couple months? Then this gets interesting, because you can apply these once, do the fine-grained updates as you mutate it, and then when the transition ends, just diff back automatically. This is the Strello demo in a really, really clean API, because you could just like go, okay, if like this add to do doesn't have to be add to do. This could be like any number of actions. You can be like add to do, new item, do this. This is the mutations that come in, and then you write the merge function right here, and then you don't have to call reconcile yourself. It just basically all works and cleans up itself when the transition's done. So you just literally have like a switch statement of like on the different actions that happen. And the cool thing here is, instead of on every new one you clone and stuff, you just do the one fine-grained update, and it will only call it with each message once, and then apply each fine-grained update. And then if the optimistic update matches the final return value, then hopefully when it diffs back out, it will match and do no further work and not re-render any more components or whatnot. So this kind of gives you back fine-grained updates with optimistic. There's no cloning or kind of weird merging, and it makes use of the projection technology that we've been using under the hood. What if transition returned a promise for when it finishes and attaches? So you could do something like start view transition. Yeah, the problem is And this is how people do install today. But you understand the problem here is this awaits for the whole thing. Like, what if there's async happening in the transition? The second you call start view transition, the outer view one from the document, it freezes the API, which means that the whole time you're doing async, it actually freezes the UI. Like it's not interactive anymore. You want the time inside the callback to be as short as possible. So you basically want to do the transition, resolve all the async stuff, then call start view transition right before you actually do the rendering. But because this is async, the start view transition, there's like awkward timing where you don't want to render too soon. What if the transition fails at some point? Will it revert to the state? No. Yeah, I think I already kind of went through this. Yeah, I mean, if it fails, you mean the optimistic state. If it finishes, failure or success, it will revert. It will revert the optimistic state regardless. Optimistic state is just, it's like pending here. It's like it was pending, now it's no longer pending. So yes, optimistic state only lasts the life cycle, the transition, success or failure. Basically, what I'm arguing is transitions can't fail. The operations inside them can fail. The way you render everything can fail, but transitions themselves don't fail. They just they don't error. They basically happen, and they complete successfully or errored, but they don't fail. They're just a scheduling mechanism going from point A to B. If you remove the transition, it's the same thing. A to B. You can't. They're not transactions, right? But yes, it will revert the state on transition end, because this is using projection, which means that it is what do you call it? It's derived, so it doesn't. If you can see my recent streams, it doesn't actually mutate the source data. It actually creates kind of reactive wrapper around the source data in a super fine-grained way. So yeah, not my last stream, but the stream before, I actually showcased how we could do derived fine-grained reactivity, and this is like a perfect use case for that, because it basically doesn't impact the it doesn't impact the underlying list, so you can always just get back to it. I see two benefits of this API. It separates the two halves in a way that makes the logic seem simpler. It hides the implicit diffing. Secondly, it turns object updates back into events. It doesn't assume you want the form data, you decide. It also doesn't care the shape. You can merge it with the actual list or keep it a list of optimistic things. You can have one handler for multiple messages or one type of handler. The biggest question, as always, is there a more basic primitive here to just handle optimism without the projections? In reality, solid, you'd almost never want the immutable form for anything with any depth. Basically, if you far enough to have a diff function, you want projections. So maybe that's the stance. No incremental function without it using a projection. But that's not true. I actually figured out a solution to this. We could have the setter function pass in the previous state. So if you want to do immutable diffs, it's like solid signals. You could have I think actually I have this in a different hackmd. Sorry. I should actually publish this one. Sorry, share the one I'm on right now. Publish. Sorry. I should have copied this into the notes already. But the other hackmd that I'm working on right here, yeah, I realized that we could also have the setter in the simple non-diff function version, like basically on the signal version. We could pass the previous value in, so you could merge it yourself, which is slightly different than passing the diff function version in, which uses the projection in the middle, right? You guys can see the difference here. This one, you just like pass in the item. That would be the new item. You do the merge in the projection, which is a mutable, and then setter function with the previous value. This is it's like a single signal setter function essentially. So then you could do here with the simple version. The difference is this merges it with some actual derived state, and then like you would use this if you were just collecting the messages. Like in Remix, the to do demo, and this is the same as Solid Start, we don't our use what's it called? Use action or use submission. Sorry, use submission pulls out optimistic data almost in this form, where it basically pulls out the list of messages, like the things that you save, like each entry you submitted on the form. It doesn't merge them, and then you use this ephemeral state to merge them in the UI. Essentially, like you go, okay, well, if I have a to-do list and I want to have I have an add to-do action, you basically, as it's going, you add the to-dos on this state, and then you have a second for underneath looping or map function looping over the new to-dos. So the original to-dos are untouched and the new to-dos are added in the end, and this only contains the new to-dos, and then when it finishes, it clears it, right? Whereas this version, you would actually pass the original to-do list in here and do the merge in here, fine-grained style. This is better if you want to like in the Strel demo where you're like moving stuff between board columns and want to do all this stuff. But then everything basically feeds through, like I call this optimistic only, but like you could, if you did it derived, like in this version, this isn't optimistic only. This is list with optimistic if thing. And then from here down, you use this version of the list instead of this version throughout your UI. This version actually merges the changes like as part of the primitive, and then you render the previously merged changes, right? As I said, this is great for the simple case. It's the way actions work in Solid Router. This is much more powerful and making like advanced optimistic UI updates, I'm not going to say trivial, but much easier to get right. Second, are these localized? Our current API has nice trade-off being declared globally. I guess our action could still work this way. Yeah, I was basically showing this, but actually I think the action API would probably work like this. But yeah, I'm showing that we could keep Solid's current action API in the router built on top of this. What's cool about this though is if you look at it, you know how today our transitions return pending? This mechanism works for both optimistic updates and normal transition like pending states. And I think that's pretty powerful because you control what's pending. The thing that's always bugged me about like is pending or returning stuff like that is like now if you want to do something special with it, you end up having to derive from it, where a lot of cases maybe you just have two states and you can just feed them in here yourself, like these optimistic states. You don't have to like try and derive them from a signal to give you. You're the one who gets to choose the signals. I think this is a much more sensible API. I was already getting away from our current transitions, like returning the pending state. That's why I was like looking at stuff like this, where it's just a signal. But I think this is actually even better. Managing errors. This all works nicely for happy cases. How do we see errors? Things on the read side naturally error when they're used. Things on the write side have no such ownership. I don't know if it's responsible for optimistic updates to contend with that, but historically they have for us. I think the answer most of the time is you don't want to upend the rendering. So the key to this actually is how you manage to return value from the action itself. So the idea here, is when stuff errors, actually this should have probably a resume in it, but when stuff errors, handle it in the action. Not don't expect again, if we make a specific solution for the router, like we keep our current action APIs because they're convenient, we'll wrap that logic for you. But generally speaking, using these like generic low-level tools, is errors are not tied to optimistic updates or pending state. You manage them right now. Obviously, this doesn't work great with progressive enhancement. So like to make it work, there will be wrappers around it, like the use submission from the router and stuff, to like have these seamless things. Like I picture our APIs in the router here actually staying basically the same, but it's cool to have them built on a more baseline primitive that works in the more general case and is much more powerful. Patterns for async data. What do I got here? Yeah, I was started kind of wondering. Yeah, as I started working through this, I realized that that because I've showed this before, but solid 2.0, when you pass a function to signals, they become derived signals. Basically, they become memos that are writable. And similarly, if you have a store and you pass a function to it, they become derived store, which makes them a projection that is writable. Um, and I started noticing as I was playing around with these that without transitions, like just on the base case, you might do this a lot. You might fetch some async data and then turn into a store, basically, by diffing it. This is what the reconcile function does. And then whenever the async data updates from the server, you diff it, and otherwise you can just mutate it like a normal store. I can see tons of people using this pattern for doing like fine-grained store updates on async data, right? And in the sense, if you put these together, this is create async store, right? It's not too hard to see how these compose. The diffs the data wherever it comes to the server, but then you're free to override it as much as you want. It's basically the granular equivalent to a derived signal. This technically has optimism built in because you're setting the store and then you fetch manually. But when and how you say the data is up to you. It is very client-centric thinking. Conversely, with transitions, you might do this. You might go create async fetch data, right? And then create optimistic, store mutate, and then use those things to like I've shown before. You've seen this before. It's a reducer, right? The difference here is the lifetime of the ephemeral state is set by the transition that uses the mutate function. Basically, you can't update the store without also scheduling a transition that refreshes the data. It's a much more constrained pattern, but it automates a lot of the pieces. Both approaches use projections under the hood, but the latter is more guided approach, right? This is kind of like the you can do anything with solid approach, and this is like the happy path, like use the features properly approach. Okay. Should all projections look like this? I was tempted, and I went through this kind of side where I was like, what if projection API always looked like this, where you had like a baseline that you could derive from, and then you could like do this, because it kind of makes sense, you know? But what I realized is for this API to work, you have to be able to do the diff at the end and know how that diff works, which means that if you want to be performant and actually diff against the projected data and not like lose things in the intermediate steps, you have to wait till everything related to this projection is like all the futuristic stuff, like all the optimistic stuff is basically resolved, so that you can get rid of it and rebase it when the base happens, which actually turns out difficult to do manually. Transitions manage this for us, or can manage this for us, because transitions have a set guaranteed finish time, and you can go look until these things are entangled, until the transition's done, we can't clean this up. So you could be running multiple transitions kind of and getting entangled in multiple actions as you go, and be living in optimistic state for a while until you finally stop typing, and then optimism clears out and you're done. But basically, as long as the final diff happens when all this, you're sure that the server has all the stuff, then you're fine. But in the general case of projections, you wouldn't know that, which makes this not a suitable API for projections in general. That's the short version of this long write-up. Yeah, the fact that it makes the win here is the Strello demo literally turns into this, which is just beautiful, because as I said, it's finally as easy, if not easier to write than like the React version of the code, and it's way more performant. So because it does fine grain all throughout. So I'm pretty stoked on that. But I haven't implemented this yet. This is the design thinking here. Yeah, use action state driving people crazy. We're going to get to in a second here, because I'm talking about the API design. I think actions are where we go to next. Let's talk about actions. I've done this one. What do I have left here? Let me just look at topics. Single feature we already talked about. Okay, actually, this is related. Yeah, what's my last hack MD? I just want to see if it's relevant to anything. Is create optimistic the right API? Okay. I might not get to this one today. We'll see. This is you have to understand stuff on the other side before we get to this one. So let's continue with let's actually go. Yeah, now's a good time to go address all the Twitter stuff related. Yeah, because I'm trying to remember where the best conversation for this happened. I think it actually happened on Blue Sky. It's hard when you have everything in multiple places. Oh, I forgot to say I was live. Oh well. Okay, cool. So let's look at this video and see what's happening. Okay, start at the beginning. We have 5 buttons on the screen, okay? Right? And clicking each one at a time, okay? And you see these fetching sequentially. I'm actually not sure if it's not just his clicking that's causing them to go sequential here. But the more important part is these 2 are finished already, but these still say acting on them. In fact, these 3 are finished and still saying acting. Let's keep going a little further. All of them are finished except for the last one, still saying acting here. And then finally, done. The answer is because there's a single future in transitions. These are all kind of seen as they all get entangled, right? So there's a comment here on this post that says, "Is there no way to use server functions in React without their pending states all being tied together?" Which is fair. And the answer is no. Basically, if you want to use transitions, you can use server functions without transitions. But if you're using transitions, then the answer is no. So yeah, this gets where the confusion starts. Ricky goes, yes, they're parallel by default in React. You may be using use action state in which you're opting as serial processing or doing the pending state and async transition, and all transitions are entangled together. Until we build parallel transitions. Okay, so one of the things is use action state, like their form processing version, actually forces them in order. But this one you can see it's not in order because it fetches, like it's fetching 3, 4 at the same time. If this was use action state, it would do the first one, finish, do the second one, finish, do the third one, finish, do the fourth one, finish, do the sixth one, which is not great. You know, there was a whole controversy about this because that's like the default behavior, and no one was expecting that from Next. I, however, in my retweet here, actually defended the React and Next position on this stuff, and I want to explain a little bit why. Not the use action state thing. I don't think almost anyone wants serial behavior like that. But this isn't serial behavior. This is just all the pending states being entangled. In fact, which means that it won't update the UI until the last thing comes back. And there's a very, very good reason for that, right? And I think we'd have to do some Excalibur to talk about this in a second. Yeah, that's all I want to know. Use action data, you opt in serial processing, where else transition globally tied together. I disagree with your take on APIs. Of course, this is artificial, though. How should I test the worst case? You're probably right. I do want to use optimistic updates here. In general, I probably won't suggest using action. Use action data, how they behave. Also want to have rules without escape patches. Plenty of websites have good Wi-Fi, clicking around, and having plenty of states all tied together. Single would not be a pleasant experience. Actually good and convinced. I'm sorry, I don't use forces this. Blah 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 blah. I think features that use actions for this bear. It's opt-in when you option not use action, you raw actions and start transition, which run in parallel. Then you need to handle race conditions and out of order states yourself. Saying that use action is required to use action, but it's not. You can change your thing. But the thing is, these are in parallel, and you're still getting this behavior. which is why I want to flag this out. Okay. So let's talk about this. Why do I think, because I sit here, I need to remember to talk about this in the next stream. What React is doing is quite logical here. I see a lot of parallels between actions and use effect. They break the dependency graph so you can no longer automatically be smart about what they impact. Even with better async primitives like we installed, our graph is on the get side. It's derived. We can trace the state change to it appear in the UI. Set user ID, get user with ID, do this. I showed this a moment ago when I was showing Dev's demo, how we could like basically trace through this stuff to do suspense, error boundaries, even transitions. But actions don't tell us their downstream dependencies. Like use effect don't tell you what state to write to. This is basically the async version of the same shape of problem. Anyways, food for thought. What I'm trying to say is, and to be fair, the live view guy was nailing Remix about their optimistic updates, saying that it wasn't safe. And it's a very similar conversation here for why we have to use transitions this way. Because a lot of people see this kind of behavior and like, oh, this sucks, I'm not going to use it. And then they actually introduce a bunch of race conditions and they try and solve them, but then they miss a few cases, generally speaking. The problem is that it takes specific knowledge to know that you can't merge these together. Because as I said, it's not too hard for us conceptually to use the reactive graph to know when we can merge different transitions on the get side. But on the action side, we don't know what the server is going to be like. Oh yeah, invalidate this data now that you've done this action. We don't know that. And the problem is this. Okay, let's draw this out. Let's look at some kind of. I'm trying to think of how to best show this timeline. So let's use solid lines and let's do some kind of fill in background color. So start with red maybe. Let's fill. Okay. Because I'm trying to think of like how to show this in terms of timing, because there's basically the first step is let's do medium. Initiate action on the client, okay? Like, let's do this. Right. And then of course. And then the next state here is apply mutation on server. Let's give it a blue. Okay. And then I mean, it's actually I haven't drawn this one before, so I have to actually think about this a bit about where we want to yeah, I think I'm going to need more steps than this. I wanted to do it like this instead of a timeline though, because let's see if I can get it here. Initiate fetch on client. And then finally get data from DB server. And then, sorry, I just got one more stage, which is update UI and client. I mean, it's a little bit simplified. I'm probably going to need more steps here, I think. Do I have enough of these? Colors? Probably not. That's fine. I'll use these. You can this has mostly to do with optimistic updates. So if Next doesn't have optimistic updates, or Next, sorry, then you might not see this, but this can always happen actually. I think this has, I mean, a lot of solutions don't solve a lot of these edge cases for you anyways, which is why sometimes like when Jose was going off on like the LiveView guy on this stuff, I was kind of like, yeah, and so has every client-side application for all of eternity. So like you just have to manage this stuff, you know. But I want to show that there's this sequence, right? And the challenge is these things can happen. I'm going to shrink it down a little bit. These things can happen with different timing, right? Now, it's not until we get to here that we know with an action like what the downstream impact is. This is when we like this part up here, like get is here. And I'm not gonna include single flight mutations for a second here, but it's the same conceptually thing. Like I'm only keeping this for a second, but I just want to point out that there's two parts of the cycle. There's the post and then there's the get. Right? There's the mutation and then there's the like, you know, revalidation or whatever. Like, it's true that this could just return the data with it immediately, and then, you know, but the problem is like the impact of this could be more than just the scope of what launched it in the first place. This is why we have stuff like TanStack query. Why, you know, we have loaders at Remix working at a fairly global scale at the route level. Like there is this part of the cycle, you know, React server functions that they include their server actions. I guess are now server functions to basically do this and then return server components, which is kind of like the get. Like there's this full cycle, right? You post to a page and you get the next HTML, right? This is common. The thing is, if you have multiple of these things going at the same time, okay, right? So let's grab another one of these. And let's just offset them a little bit, right? This is the simplest case, right? In the simplest case, as I mentioned, it's only on the get that you understand that they are actually entangled. So if we just don't do anything special and assume that transitions are not entangled until they hit a reactive graph node change, the simple case is actually fairly helpful here, because the simple case, when you're doing the fetch on the client, you set the state. This is when the transition classic starts. And this CellSolid 1.0 actually works with its stuff. I didn't actually wrap the action part in the transition. There's a reason I want to in 2.0, but initially I just did it here. So what would happen is when this gets to here, it realizes that it's the same transition. It's impacting the same data set, right? If these would be entangled, right? We only care about the entangled case. In the not entangled case, then yeah, these things can go independently. We don't really care, right? But it's when we get to like set, you know, we go, yes, we succeeded, refresh the data with this ID, you know. At this point, we have our more synchronous, like we have the full reactive graph in this get side. And when this hits it, it can see that it overlaps with this because it's happening at the same time. And what's beautiful about this is it knows this one happened after, right? So it actually will cancel out this one, so to speak, right? Because of like create async um, essentially um, knows that like it handles these kind of race conditions, which is great because you know if something weird happens here, like you're doing this one, and it suddenly for some reason does this. Sorry. If this happens, you know what I mean? It's gonna go. It's basically gonna ignore this, and it's just gonna continue on from here. Like this part just won't exist. It'll just be like bye bye, right? But so you get some protection automatically simply by the fact that because these get locked in a transition sequence that and the uh, because of the it actually technically because of transition will wait for them both to come back, I guess, which is arguably but actually if they're the exact same data being fetched, it will be canceled if it's the exact same like data source being updated because of the internals of create async. It'll just like basically cancel the first one, right? Okay, but basically, this already is kind of helpful. The challenge is what happens if so most of the fetch side stuff gets handled automatically now because of transitions and async primitives. But what happens if these two miss each other? Like if I move this just a slight bit further to here. Now, oh, actually, this isn't quite right. I can move it a little bit further. We gotta move this to here so after this gets back, right? Because this can happen in solid today. The transition ends before this green part happens. So when this goes to go, it doesn't actually see that it overlapped if we didn't start the transition here. So, and it's possible, depending on when this apply server mutation on the server and this get data from the database happens, for this apply to happen before this get. Do you see what I'm saying? So this to actually get the change from this action ahead of time before it actually like should, right? And as I said, in a basic case, no one actually notices this in general. Okay, I can zoom in a little bit more, but I'm pretty wide here. Let me see if I can move myself down. Maybe this is better. What I'm trying to get at is it's possible for it to save on the server before the get cycle happens, and for this to update the UI with both changes, and then go to update again with both changes. I mean, this is not a big deal for normal UI, but this is actually a really awkward for optimistic updates because because the timing of this fetch happens after the transition ends, it doesn't make them the same transition. If you only start the transition on the get side and not on the action side, which means that like if this optimistic update was to add one item and then this was to add another item, right? So you've now got two items sitting there. like extra items on the end of the list. When this finishes, it goes, okay, I'm done my transition, and they didn't get interlocked. They didn't realize they were the same transition. So it removes the one item that it was intending to. The other item stays there, but it returns the data for both items. So briefly, between this rendering and this rendering, the second item is going to appear in the list twice. Once as new and once already there, right? Because it returned it because it already applied the mutation, right? Because these did not get interlocked. Like they didn't entangle because the transition started too late. Similar things with deletion, where like if one needs a deletion, you'll see stuff delete and then show up again and then delete again. These kind of things can happen with optimistic updates if essentially these aren't tied together as the same transition, but they don't know they're the same transition because the transition ends before this one actually figures out its data dependencies. This is kind of the challenge. The funny thing is, as I said, without optimistic updates, you wouldn't probably notice this because, I mean, we're all kind of accustomed to this kind of behavior. Like you're on a website and a different user updates the state, not you, but like a different user updates the state. And when you do a save, not just your new data, but like other data comes in too. It's a little bit jarring, but you're like, oh, someone else must be on this page, right? Yeah, I don't have time to make these kind of demos per se. But yes, I mean these are just conceptual. Like I think Jose from LiveView on Twitter, I maybe dig it out a while ago, did a decent job of like picking apart a website that had these sort of issues. You've probably seen them before and not realized the cause of them. But yes, this timing bit is a little bit awkward. The ways to fix it, right, is if you entangle this, then you know not to update the you know not to do the update until the end here. Solved. But you don't know the entanglement. I also just realized the solid events creates a graph for the post side. It can tell us everything that will be updated right at the beginning of the event. That's interesting, right? Because one of the API choices is basically to tell the transition like this is what we'll update, but it might not know because the server might fail or work a certain way, and like you can dynamically choose what gets invalidated at mutation time, right? So like it's the other solution to this though that I was thinking about is if you're okay with this happening when optimistic updates aren't involved, we could just entangle. Like you have two options. You basically have to say, look, all actions when there's actions involved have to entangle, right? You can go like you can do the get stuff as much as you want, but as soon as you have actions, they're going to entangle, which means you're basically back at this React example. It's not unreasonable. If they didn't do this, stuff like I'm showing you right now in the Excalibur can definitely happen, especially, and these are not the kinds of things like, as I said, people are accepting when optimistic updates aren't involved, but as soon as optimistic updates are involved, this is not the pro developer's fault for not handling these edge cases. This is the framework's fault. Like React knows that if they didn't say this was the behavior, like, and you had your optimistic updates popping in and out, like they can't offer an optimistic primitive and not handle this case, right? So like it makes perfect sense for it to work the way that it does. I'm not action state, that's a whole other thing, but for transitions in general to work like this, that they encapsulate they don't know what's going to happen and they encapsulate the action state. But yeah, I mean, what I'm thinking is interesting is if these are related to the same data and they feed through the same optimistic updates, that could be the indicator that they entangle, right? Because without optimistic updates, you might not actually care if this happens. Do you know what I mean? So that's my working principle, at least right now. We'll see how this goes. But there's a whole bunch of situations you get when these timings compress or change or shift and happens before. Half of them are resolved by transitions simply from the synchronous data fetching point down, like just having transitions. The other half of them can be solved by actually encapsulating the whole process, right? Because now it's only if you start the action after you started the UI update that they're not potentially entangled. The beautiful thing about actions generally is you can, I mean, if you'll set the optimistic updates up front. Now, it's possible that you can be in the middle of an await chain setting optimistic updates, and then you won't know until the middle. So like the approach that React is taking right now is the only actually foolproof solution. It's just there's a certain question here that if we basically assumed reactive graph entanglement using stuff like the optimistic updates, could we get there? Like one of the tools that I have in Solid that they don't have in React is I know the graph, right? When React talks about parallel transitions, they're kind of talking about transactions, I think, and then figuring out how to merge them, and like it's kind of complicated. Whereas when I'm talking about parallel transitions, I can just like go, I know what's impacted from a graph standpoint. Like in React, the challenge is because the UI components pull lots of data together, co-location in the UI is actually what decides the thing. So then you can't really isolate any like thing within the same tree, you know. Whereas because again, transitions could conceptually start from the global level. I guess it's where you set that state. So if stuff's in the same component, then you're kind of messed. Like there's nothing you can do. Whereas when the fine-grained approach, you don't actually care what component it's in, only if the graph overlaps. So I think this opens an opportunity for us to have different solutions in the space simply on the fact that we can actually know the dependencies of the graph. And this is what I'm talking about. Some of the applications of signals that go beyond what we can do in React today. But yeah, I mean, getting back to this thing. There's a comment on here. I thought there was a response. Maybe it was on the Twitter thread. Let's go to X. No, it's probably deep somewhere in the comments on the Blue Sky thread then, because it wasn't on my top level thing. 111, yeah. I think there is a comment. See, the React is enforcing them in order. The requests are parallel. They just get grouped in the same transition pending state. So make like use action state. It's great. This doesn't do what I expect. Now my UX is very specific. Where I can don't use it. Do this stuff. Back to square one. Maybe it's a bit simplistic, but every time I touch new React 19 stuff, this are into it. It's like I like remix fetchers. I get them to problems you described are mostly backend problems. I want server functions to work with fetchers. Blah blah blah. Yeah. So he's using use transition, not use action state. I get it, global pen. The way not to get them is don't use transitions. Now I know, but it's tricky because if you don't use transitions or something like this, it's very difficult. Sorry, where's my Excalibur? It's very difficult to handle these problems completely because the number one thing you can do is control the sequence that these happen from the client, right? You can go like give each of these an individual ID. But you also have to know when to say cancel, which is fine. I mean, if they're the same fetch, or same action, but like you also, but if they're a different action but related to the same data, like there's so many permutations of how this can go wrong. that you basically end up building something very similar where you act like hold applying the state, kind of again forking it in order to get yourself there. Just so that I'm interested to see, but my gut feeling is in order to avoid doing what React does, when you have a solution to similar things, you're probably missing some edge cases in the general sense. Like maybe you have a specific solution where you're like, oh, in this case, do this or use this version of the API. But in a general sense, you can cause this kind of behavior. Probably. I can't like prove that, but my gut feeling is that there is some way to cause an issue if you're not entangling in these, just because there's so many different timing situations, and at the point where you're basically forking and creating your own updates, they again, this is kind of like when I'm talking about the physics of it all. They have to behave a certain way in order to ensure this behavior. I'm not looking at this as a React specific way. I'm looking at this in the general problem space sort of way, like we did with transitions or whatever, or async. The shape of the solution can only look a couple of ways and with certain caveats. Now, you might not like the caveats that the React team chose, but I think looking at this from a general sense, that has to be the solution unless you have some like clever trick up your sleeve, like maybe use the dependency graph or something like that. Whereas I think if you're already building in React, you're kind of stuck with the same tools that React has given to you, unless you specialize. But then if you specialize, you're not solving the general case. So I'm like, yeah, that's my gut feeling here. So yeah, this is why transitions are tricky. I think the most reasonable trade-off that I can think of right now is not caring about this if there's no optimistic state, because then you're used to that as a developer on the front end. It's only when you introduce optimistic state that you kind of feel responsible, that you're like, look, I can't have it be weird and janky. It needs to be predictable. When it's my own state and my own changes, I can't have stuff appearing twice or disappearing and reappearing. And in that case, maybe we can use the graph there. Anyway, I think that's it on this topic for now. But let me continue, because I want to show off a bit of what I've been working on. This is a tricky problem. I don't think people appreciate how it kind of has to operate like this. And I mean, this is my gut feeling on it. It's funny because I came to this independently. You know what I mean? This is not me like copying React and agreeing with them. I've been actually just working on this, completely not completely aware of all the React behavior. Like I only found out about use optimistic like a month ago. I mean, I knew about it, but I never looked into it. I didn't really think about it much because it wasn't the topic I was on. But so yeah. Anyway, okay. Let me get to the demo that I originally showed off that I wanted to talk about on the stream today, because people probably saw this demo, and let me close this up a bit. And they probably thought that I was basically showing the answer to this Twitter post. Like, look, it looks the same, right? They're independent. The key difference here is that there's no post here. This is purely get. So yeah, in case you haven't seen this, I'm going to share this link in the tab. This is a very early look at 2.0 transition approach, and let me kind of show the basic example. Basically, I'm using real DOM elements. There's no JSX compiler. This isn't like solid, like a solid build. This is just me literally in the playground hacking the solid signals implementation, and then just using DOM effects directly. But essentially, I made a component that has an ID that you can increment, has an optimistic pending state that gets sent to true and false, has async data based on that ID, which literally just appends a D to the front of the ID. Nothing creative here. Then I create a div and a button, and then set the text, and then on click, run a transition, which sends pending data to true and increments the ID. And then, some div stuff, just initial loading state, and then it has an effect. This effect listens to the ID, the return data, and some counter that's global counter that just keeps incrementing. And then I have a different render effect that listens to the pending state and like if the data is pending, and then sets the opacity based on whether it's pending or not, right? Which was the optimistic data from the transition. And then finally, I grab my app and then I append 2 copies of the component, one with name 1 and one with name 2, and we set up our global counter. Okay, that's a setup for this. Oh yeah, this I have not. I have not made this work generally, practically at all. Create effect is also different because create effect it doesn't participate in transitions. If you remember, this was the outcome of our discussion. I mean, we could try it on stream and see what it does and see if it's what I expect it to do, or if it just errors out and it doesn't work. But generally speaking, because for the same reason here, this effect is reading from phrase up here, and it's not suspending the whole phrase counter. We said that only render effects participate in these node collections because this doesn't have to do with rendering. So this gets held up on the graph when it's like it only runs when it can resolve async, but it does not like throw up to a suspense. This is how we can have an effect that reads an async data above a suspense, whereas the rendering happens under suspense. Otherwise, it would move all the way up. Okay. Similar idea when working on this example here. So render effects are key to this example working. Okay, so it's like just broken. Okay, fair enough. Yeah, so basically, when I increment this ID, you're going to see it turn gray, right? For 2 seconds. The counter's at every second, so it goes 8, 9, 10, flick, right? And if I jam this like 10 times, like you see that it actually waited until the end to actually show the updated data. And the key part is this count keeps on counting throughout. I told you to actually prove transitions, you actually have to have a counter going, because that means that there's a version that's locked up on here, and there's a version that continues to count up in the foreground, right? But the key part is ID 9, and like these are always the same. They're always consistent. The ID cannot get out of sync with the data, right? And that. Now, as it turns out, and obviously I did this very easily because I just made it all into a component that does it. In real app, it's more complicated. This transition is completely independent because it doesn't share any part of the same graph, right? It sets a different signal, has a different optimistic update, has a different async. So there's no reason for these to entangle together. So I can hit this 5 times, hit this 5 times, and they can run independently here because I can create multiple transitions at the same time as long as they don't entangle. If they do entangle, that's what this case, when I hit it multiple times, that's them entangling. That's why they wait to the last one. But these ones are completely independent. Yeah. So, I mean, that's the basic example. See, if you don't have a transition in this example, and we do this, what ends up happening is ID goes and then that goes. ID goes, then that goes. Yeah, you can hit it like 6 times, 7, and then it'll jump up to 7. That's create resource or create async, sorry, managing managing the race conditions. And again, this is not blocking and it's parallel. This is what happens when you don't use transitions, right? But this is what tearing looks like. Listen, what's cool about this example is there's actually no suspense anywhere in this example. I can show this off because of the way we do tearing. But what I'm getting at is this is fine behavior for some stuff, but and you can always go back to this. But transitions can give you that guarantee. And as I said, you need to add the affordance, which is why there's this optimistic update, because without the optimistic, it doesn't, there's no, like, I mean, you can visibly see it. I'll just cross out this effect for a second. Without the optimistic, there's no immediate feedback. You can't tell, what's going on, which is why, like, transitions kind of need that, which is why they use transition kind of ships with appending. But I was talking to Ricky, and he said that they literally, like, they just put the pending state that comes back from use transition is just one of these, like, exactly like this with exactly this, and that's how they basically model it. In terms of the code, if you guys are kind of interested in how this kind of stuff works, I can give a quick run through. The transition function is fairly straightforward. It creates a new transition, which is a kind of queue. If you haven't seen most Solid 2.0 stuff, you probably don't know too much about these queues, but it's basically a way of managing running. Like when it flushes, in this case, it sets the active transition. It runs the pure queue, and then it checks if it's finishing. And if it finishes, it actually runs the more effectful queue. But what's more interesting here is that the graph cloning. This is how it merges. It's actually fairly straightforward. Funnily enough, if you pass in a node that already is associated with a transition and it doesn't equal the current transition, then go through the sources for the current transition and merge them into that existing transition. Basically, like, just literally just add them to all these sets, essentially, and arrays, and then say that that transition is the transition, and then return the cloned version for that node. And then here, the cloning, I'm just cloning the computation node, removing the disposal elements and the children, essentially, and then creating a backlink to the original node, and then adding it to our transition, and then going through its list of observers, cloning them, but also adding them to their observer list, which is important because sometimes the nodes don't exist in both places. Yeah, you don't really need to know that. And I guess the other fun part is what happens when the transition ends. Basically, if it's done, or it's scheduled, or there's promises, or all these things, you can't finish the transition. You have to wait because it's fine. It's scheduled, it'll do some work, and then it'll try finishing it. But then at the end, what we do is you go through all the sources, and if they're for this transition, not for this transition, or the source equals a clone or whatever, then we can continue. Otherwise, we remove the backlinks, those extra observers we have. We dispose of the original. This is when you finally do the cleanup on the original nodes. You assign all the new values into the source, remove the transition fields, and then once you've gone through all the sources, you set the transition done, delete it from the overall transition set, and then run the effects, and then reset all the optimistic updates. And that's basically it. I mean, I still got to do more work on it. This is very, very basic, but it's basically what I described earlier in terms of that. The trickiest part to the reactive system, I think, is that like in Solid 1.0, these should get tree shaken out because you can only set the transition in the transition function. But essentially, sorry, transition. There's a lot of hooks in that like look for if active transition. So this code should just tree shake or like codes like tree shake right out of the bundle if you don't use the transition feature. But there are a lot of places, not this one, this is the transition queue itself, where in the core of it, sorry, let me see if I can get to it. We have to do stuff like if there's an active transition and if this is a source in it, then get the source, otherwise use the original source. If there's like this is when we are creating computation, like a core like memo or something. If there's a transition, set the transition, set the sources. Like there's a bunch of these hooks. Whenever we read a reactive value, it has to check if it's there. If there's a transition, wait. So this code does increase over everything, but almost always it's controlled by an if active transition, and which is cool because if this can never be set to anything but false or null, this code will be just removed from your bundle. So at least that's good, but it does make maintaining the code a little bit trickier because there's a lot of these in place things because I don't clone. Even though I clone the sources, I keep the source side of the graph the same nodes as I mentioned for the reasons earlier. So there's a lot of touch points, unfortunately, which until we get I hit all of them properly, we might have some bugs. But that's generally it. It's doing what I want it to, which makes me pretty happy. Yeah, I wonder what happens if I change create effect to create effect. Does this just completely die? Transition already completed. Okay. Yeah, this might not be that hard to debug. Do you know what it is? It is delayed though. Interesting. See, I think what's happening. Yeah, that's interesting. Yeah. Basically, these nodes shouldn't be getting added to the transition, but I wonder if the fetching still is. So it's like in this weird state where it's like the fetching finishes and then it goes like, yeah, I bet you that that's what's happening. What's happening is that create async registers with the transition. So it's like going to do its thing, but then it has no effects nodes. So basically the transition completes. It goes, okay, I'm done. Like you never see go depending here, right? But then when the async data comes in, it goes, okay, I'm going to continue this transition. It's like, yeah, you know what? Can we fix this right now? Create async. And transition to done and not done. Because if it's done, you don't want to do this. Yeah, okay, fixed it. It's funny though. What's funny about do you know why this works like this? Create effect doesn't tear. Only create render effects tear. Create effect actually doesn't tear, which is why it's holding. See how it's not counting? I just created svelte. Right? See, it's holding it in the past, including R39. So yeah. Yeah. You wouldn't use this to render. This is logical. Like this is behavior. Like this is what happens if you block without transitions, right? but yeah, I mean, this is a good showcase because if this wasn't rendering to the DOM, but doing some other side effectful thing like creating logs, this is what you'd want, right? Create effect is designed to be consistent, actually, um, and not use suspense. It's actually an isolated, consistent thing. This is what split effects give you. Split effects give you this great benefit of consistency. So these stay in sync with create effect. It's just that you know you don't want to block things. It's only within the scope. Just because these are doing DOM operations that it's doing that. Where um, I think the more logical um, behavior here would, for rendering, like let's go back to rendering, would be would like if you want to, yeah, if you're not using, like if you're using transitions, good, and if you're not using transitions, there. But in no world should count ever stop counting, right? Yeah. As I said, there's a different. My opinion, and it could be wrong, but the thing that I've been working on with Solid is I think that rendering and the UI have slightly different expectations than than like than like just normal effects. And I think the biggest difference here is that rendering in the UI, um, you need to show that consistency, or purposely opt into tearing, or purposely tear, like make a decision. Like you have to make a decision on this. But the one thing that no one ever expects is for stuff to just freeze up on you. Okay, yeah. Salt says the mechanism not to block unrelated updates. From what I can see, I've seen it should keep the count running as well. Yeah, I believe so. I think it depends on how you write it though. Like I think you can entangle them if like it's like this where you put it inside like the same text node. I think in general though, if these aren't in the same effect, they're not going to entangle. Right. I did this on purpose to show it in the same effect. Um, if these were not in the same effect, um, then count wouldn't freeze up like that, right? We're still using the graph to make this determination, and I think that's basically the gist, right? I think quite often these aren't in the same effect, so like Svelte's approach gets by most of the time, and that's pretty good because when you have an like yeah, I guess I mean this is fairly reasonable if we change this to create effect, right? And then Uh, trying to think of how to make this work. I guess I can just make like a different. s- Trying to like think of how not to put this in the same effect. I mean, it's not count. Um, hmm, I have to make div two. Maybe I'll make it a span. Hmm. it just called cow? It's like, what am I doing wrong here? All right, I know what I'm doing. One fun part with split effects, eh? The second function being a function. Okay, sweet. And then when I do it, yeah, it no longer freezes. There we go. So I guess this is probably the more typical Svelte behavior. And so yeah, I mean it's perfectly fine. And then they have a way of injecting within the scope of the components the pending state. So like this holds up to the boundary. As I said, I think transitions are global, so that's kind of odd, but I get why this would be attractive from an API standpoint. Yeah. Yeah, that would be better. I thought Svelte's approach is to compile animations to CSS. Yeah, for CSS they do some stuff, but like I'm this isn't really animations. This is state updates. I'm talking about an async data flows. Yeah. I imagine they're smart enough to know the graph relation. One of the biggest differences between the Svelte approach and solid approach for the async stuff is that our approach is completely runtime. We actually use the basically the throwing of promises to figure this stuff out. And we I realized, and again, it was actually thanks to Dominic for when he was working on Svelte, he mentioned something. I realized that I'd already come up with a helper to see that get the previous value latest, that we could just make render effects wrap latest around this, and that would give us tearing back, which meant that but I mean, as you can see here, it's not hard with these things to model any of the different styles of behavior. I personally don't think holding as a default is as good, but I mean, it's hard to say. Okay, you made it for us, Dev. Where I got this go to my Twitch, which I haven't had opened all day, which is actually on me. I usually have it open so I can interact with chat better. My channel. All right, there we go. Yeah. Yeah, I mean, so this is graph connected. Now we just need to add a counter to this. This is from their docs, right? So then all we have to do is add a counter to this to do this, which shouldn't be hard. We should be able to go let count equals state 0, and then do something like set timeout. I'm not going to clean up after myself. Sorry, count plus plus. And then put count in here. Oh, it's not set timeout. I want set interval. Their timeout is a small delay, so I'm actually going to have to go faster than that. Yeah. Yeah. See, they know that it's not that it's independent. There you go. Yeah. So that proves that, and it's interesting because actually I want to see what the JS output is. Interesting. See, I was expecting count to get subdivided off, but it is actually it does appear to be in here, which means they must be using some form of runtime in addition to the compile time stuff to determine the uh the connectivity. Yeah, no, this is this is this is reasonable because basically they ensure that. I wonder if it's just simply because this update just runs the effect and it grabs the latest. Yeah, so the yeah, I think I understand their solution. It's like halfway between a transition and not. This so this like this isn't quite solution what we created here. Like technically it works the same way as like the output is the same, but the difference for the Svelte solution is they actually do fork the values in the signals so that when the effect runs here, essentially, like when this effect keeps on running over and over again to do this counter up, it just reads the latest values even when it's in flight. So in that way, it's similar to the solids approach of using latest. The like our however, their version of latest includes the things that trigger the async. So it's like a mini transition in a sense. Yes. Because the difference with the solid version is it doesn't include the state change. And the way they're able to do that is my guess is that that's where the compiler part comes in. Let's take a look here. Like, how do they know? I mean, it could be done runtime as well, to be fair. Anyways, not to get too much into the minutia here on the specifics here, but I understand the gist of it, right? The idea here is that they do almost something transition like in holding the values of the um, of the set, but they do so in such a way that I guess it's yeah. There has to be some element of it because they don't wrap the set. Like, where does the set happen? Oh, it's right here. This add. Yeah. Given that this is already in await, I think this might, or an async function, this might actually simplify things a little bit. It's curious to see what it would look like in a case where it's like a state set leading to a fetch, like a memo that's awaited, like or derived, awaited derived value, and then see how they determine that. But yeah, they have to be using the graph shape to basically determine, because the reason you wrap in a transition API is because when you call a set, you don't know until you actually go to set it, like you actually call it, you go, okay, what are my dependencies? Like at that point, you can go, okay, I know this is going to trigger async, but you don't know that beforehand, and you don't want to change it so that every time anyone triggers a signal that you basically transition, probably, like because if every time you did it, that would be expensive, right? So that's why my guess this is why where Svelte ends up using the compiler a little bit because if they can determine that ahead of time, then they don't need to use the wrapper. So that piece of the solution is actually um, pretty clever. Yeah, the two-way binding. Oh yeah. You're right. Like trying to scroll sideways. I was trying to see if like there's any indicator or hint that they'd be dealing with something async here, but I actually don't see it in the compiled code, which is kind of cool. I was kind of like um expecting something here to that effect. Anyway, yeah, I mean, I think this gets the result that they're going for. I think that the holding when you can ensure this isolation um, is fairly reasonable. The tricky part, obviously, is like the same problem you have with transitions. I say it's hard to make transitions the default API because people are like, "Where's my affordances?" In Svelte, you can inject this back in, I believe, by using a boundary. But people are like, you know, to be fair though, uh, do they have a? They don't have a localized reload. Can I get it here? No. Like trying to. That's. I can trigger it by changing the code, but I kind of don't want to do that. Okay. Yeah, see, it would take a long time to show up. So theoretically, you'd have a boundary here already because you would literally be loading the code. Right. Like, so it wouldn't be too hard to position in your stale state through. Yeah, this does remind me of a lot of what they wanted to do with Marco. It'll be interesting to see what they did choose to go with Marco when Dylan Piercy joins me on my next stream on September 5th and we talk about Marco 6. Okay. Yeah. Anyways, enough of this for now. I don't think there's actually much. Did I publish this one? I think this one I actually covered everything already in the course of the stream. Talking about what single future means. Yeah. The trickiest part, obviously, with these pieces, and one thing that's very elegant about the React solution is the way that they've basically incorporated optimistic updates into the same model with the transitions, which is, as I said, valuable because then you can solve this issue as well. I think the runtime approach with the latest splitting is I'm still pretty big on that approach. But yeah, it is interesting to see different models at play. Okay, where did I want to go next? Sorry. Talked about this. You know what? I mean, that's pretty much the transition topic. I might as well do a bit of this week in JavaScript because we haven't done this in a while. But give me 2 seconds while I sort that out. Okay. Oh, I just saw a comment. Use RxJS to handle concurrency. You can, and I've been getting a lot of RX comments like on my Signal streams. The challenge is, I mean, yeah, use events because they are streamlined. The problem is about these async models. It's never the actual managing of the async. It's getting the async back into a synchronous system, one where there's guarantees in terms of what you show up, like show up in terms of the UI. Like so. Yeah, let me see. When was my last stream? It's funny. There's actually okay, yeah, I covered the Rich Harris thing. My last stream would have been on July 25th. Okay, cool. Okay. And okay, give me 2 seconds. How's chat doing? You guys alive? Quantum programming. Yeah. Yeah. Has React just pushed their complexity on everyone else? I think about this stuff all the time too, because it's like, is there simpler models? But it's like, not if you define the baseline, to be what it's. God, there's so much stuff. By so much stuff, so many interesting Ryan Florence and Michael Jackson tweets to talk about. No, all right, 1, 2, 3. I'm good to go. Let's switch modes to this week in JavaScript. That way, I can get back to programming. Yeah, let's get going on this. I'm gonna start with. Should I start with solid stuff? Yeah, probably because it's just completely off the side of things. I've been loving the TanStack stuff. Me and Tanner did a stream recently where we talked about some solid and TanStack stuff and RPCs and server functions. But like, it's so cool to have a framework ecosystem and one of the largest ones in React to have solid as the second citizen, right? A lot of the times, a lot of React frameworks and stuff don't cater to other frameworks. Like when they release something, they don't immediately release it for another framework. And if there were ones that were fairly fast at it, usually Angular and Vue get the next nod, and then occasionally Svelte. But with TanStack, Solid's number two, which means that like for once, like all the new cool stuff comes directly to us. So it's like TanStack DB comes out for React. A week later, it's out for Solid, which is just awesome. So like this has been good. Obviously, TanStack dev tools and stuff have been written in Solid, like very close to that team. Tanner is amazing. I love the work he's doing. He does the stuff that I don't care to do. I focus so much on these like really low level primitives. Someone has to make the developer experience pleasurable, and that, hopefully I'm building the right stuff for him. But yeah. TanStack and most of the sync engine community is treating Solid as second class citizen. Yeah, they should, because the stuff we've been working on, I think, makes it actually a better solution than React. We just we're not React, so you have to support React first. But it's kind of like this. I remember when Jamie from Convex first saw Solid, and he went off on a tangent. He made a YouTube video and made a Convex integration and did this all in Stew. And his team had to like pull him back and be like, "Look, we got to focus on React right now because we're trying to raise and go to our next stage or whatever." It was like 3 years ago, I feel like. But like anyone who's working on a sync engine, they see Solid and they're just like they're like, this is the UI framework that makes sense for us. So yeah, I mean, yeah, it's exciting to see this kind of progress, right? And it's been part of this like yeah, solid and terminal HMR. Zig. People are just starting to like understand like the things that React has been having a hold on the ecosystem was like everyone's like, oh, with a virtual DOM you can do things that aren't the DOM, or you can go into these different kind of scenarios. And it's like, you know what? You don't need a virtual DOM. Getting over that hump has taken like a decade for people to recognize it, but it's starting. Yeah. But yeah, this is what I mean. This growth has to be thanks to TanStack and um, and uh, and the sync engine peoples, because like this doesn't look like very impressive. You're like, oh, this is a fairly flat line. You know, it's 6 months. You know, but it's because I've stretched it. 300,000, 710,000 or something. We've over doubled the amount of downloads in the last 6 months, which, as I said, going up 300 and some odd thousand isn't a big deal when you consider like, you know, most frameworks get millions of downloads a week. But doubling in that short period of time when we have not done a major release, no new features, no like literally nothing to merit this kind of growth is incredible. It means that people are starting to catch on, right? Like this is not because like, oh, you just dropped the Solid 2.0 release or whatever. This is just people picking up Solid and going, yeah, this makes a lot of sense. You know, like it, it's funny because when you do npm trends, you can like see it a little better than my graph. I just didn't want to show the history because we flatlined a little bit, but if you go here, because like the last year doesn't look too impressive either. You're like, okay, because it's stupid spike. That's why I didn't want to show the trend. See, every framework has these stupid spikes that happen, and you're like, how the hell happened? But let's look at the 5 years to give you a better idea. Yeah, here we go, or all time. Yeah, this is more indicative of the growth of the last 6 months. This, you know what I mean? 2024 was tricky. It looks like we had a like solid start, came out around here, so we had a swell, but then it almost returned. Like basically, solid start did not perform as well as I might have imagined it would. It kind of, even though like humped up and looked down, make it look down. For the most part, we just kept the same trajectory when you average it out. It just the growth was constant. Solid start didn't end up adding much to our user base initially. It just kind of kept the same trend line that we've been on since about 2023, which is a decent growth pattern. But then the last 6 months, like, ooh, suddenly that makes that trend line look like exponential instead of flat, which is good. It's just the stupid spike in the middle ruins everything. But to be fair, if I put Astro during the same time period, they probably pulled away from us. Oh no, I guess we caught back up on the Astro thing. See, traditionally, us and Astro have been very close, probably because a lot of the same users. And then Solid Start jumped it a bit, and then we kind of went down a bit, and then Astro was the thing. But then we're back to basically neck and neck with Astro, which again isn't a competitive thing because us and Astro do different things and do the same things. They're actually very complementary. But yeah, I mean, definitely TanStack using us and fixing it so it actually showed is actually probably a good sign. It's supposed to be a starter. I'm trying to. My plan for it was it to basically be our version of Create React App, but modernized using Vite and using like SSR. So yeah, I mean, yeah, it's been good. Dax, this is your comment about the whole, that whole scene. TanStack. I mean, that's all the news. More Dax stuff. TanStack. Um, yeah, I don't know. That's all the solid news that we've announced. But I actually do have some solid news that I want to talk about a bit. We've got some, and it'll come out this week, so I'm kind of ruining it a little bit. But we got some new fellowships coming in, and most importantly, we have a newest member added to the solid core team. Achilla Facina, you've seen him, on the stream before, doing the Tory stream with us. Great public speaker, has done tons of solid JS talks. Head of our DX team. He's actually stepped up to kind of lead the efforts on Solid Start, which is great because I have not been focusing in on it all. And we've actually got sorry the pun, pretty solid team now. It's funny, I know everyone by their usernames like Brennels and Brendonovic or whatever, but Kasha is on it too. Like there's a group of them that they've that have been doing a lot of work on Solid Start. More specifically, when I have not been able to focus on it, and they've been heading up like the Da Vinci, like removing Vinci effort and modernization, getting on the same bones now as TanStack Start. They've been obviously working a lot with the TanStack people, anyways, help like getting the solid integration of TanStack as well. So it's really awesome to see these this kind of coming together in an official way. And Chilla has just done amazing work for us over time, and it was long overdue for that. So the announcement should be coming out soon. He'll be, I believe, he's going to be coming up speaking at a VeeConf coming up, I believe. I haven't heard too much about that. I haven't actually looked at the site recently. So yeah, very, very excited about this. Solid JS is solid frame. I'm surprised it's taking this long to take off. Years of head burying into React. Yeah, I mean, it's just one of these things. I mean, don't get me wrong. It's not even taking off. It's just steady growth. It's really hard when the stuff is so grained. How is Solid for full scale enterprise web app? The client side part of the solution, like not the Solid Start side of the solution, has been pretty stable for quite a long time and pretty solid. Obviously 2.0 is coming out, which is probably the first considerable change in 7 or 8 years. Actually, you know what? There's a tweet here that I skipped over that I think we should talk about in regards to this thing, and you decide, For a framework renowned for its innovation, it is funny how little Solid has changed in the last 7 years. Yeah, we've innovated on features, fine-grained concurrency, hydration, streaming, server function, single flight mutations, but the core tech and structure untouched. And it's true. I forget, I was doing a podcast or something, and I was like, I sometimes forget because we're always, talk about signals, but we've actually been at the forefront of a lot of stuff. Like we were the first one to do like transitions with the signals, or like these kind of async models, right? Fine-grained hydration did not exist before Solid, right? Like people did coarse-grained hydration. Obviously, there's better versions of that arguably today with Zoomability and Quick, but streaming. Marco was first technically. So there's that, but other than that, Solid pushed forward and was one of the first frameworks to do streaming other than Marco. Server functions, that was something that we worked on during Solid Start. Blitz technically had like some kind of proxy, I believe, based, or like they had an approach to doing RPCs, but like the modern server functions started it in Solid Start. Single flight mutations was us in Solid Start. But through all of this, we actually haven't, like Solid hasn't changed pretty much at all. Like we haven't changed our templating language. We haven't changed our reactivity model. We haven't, like what did I say? When I look at React, Angular, Vue, or Svelte, the same campus data, even when backwards compatible, they've changed their structure, underlying text significantly, at least 2 times each. This is a hindsight observation, but one we could have banked on ahead of time. Like I knew. And what I mean by that is like, I knew what I liked with Knockout, so I just went in with that kind of mentality. Ironically, split effects are probably going to be the biggest like conceptual breaking change for Solid 2.0, but my original knockout wrapper that I had at my company had split effects back in 2013. Like, it's just one of those things where, like, anyway, part of this is we bet on old tech. We didn't try to use classes before they existed. Yeah, so switch to switch um, switch to real classes, decide functions were better, then add a compiler to fix. Okay, I'm clearly talking about React here, but like, because people talk about React, and not changing and stuff. But while it's been backwards compatible in a very impressive way, considering how big the scale is, if you like, yes, React hasn't changed much in the last few years. You can say RCs, but RCs don't actually change React. They're like an additive feature, perhaps. I mean, the async features, I could argue, changed it's significant, but for the most part, I could see an argument to say that React hasn't changed much recently. But let's look at the first 5 years, even, or most frameworks, when they're trying to find their footing, have actually changed as they figured these things out. Right? Create class or React, dot create create component or create class. I can't remember. Basically, they had one class and they had actual class, like extends component, which wasn't a huge change. But they had to remove mixins, right? When they made that change, then they switched to functions with hooks, which again was another API change. And then the compiler, to be fair, isn't actually as big of a change. I could argue that it's still just hooks continued, but it is enough that it, like, of a kind of a API surface level change, right? And part of this is because they tried to use classes before classes were prime time. So I get why, but that is one of the challenges when you're coming out with something new and you can start new. You don't want to start in the past. You don't want to like assume like take this clunkiness. You want to jump ahead, right? React's done this a few times over years, like force async local storage when it doesn't exist on the platforms, stuff like this. But sometimes that leads to, API changes when you realize other stuff ends up working better anyway. Okay. Nor did it start with no VDOM, then switch to it, and then switch back again. I'm talking about Vue, right? Like, and Vue also went from option API to composition API, right? They actually, Vue 2 to Vue 3 was a fairly big change on an API standpoint. They basically changed the whole way their rendering worked a couple times under the hood. So architecturally, it was a different framework, right? And then, I mean, Svelte's had Svelte 1 and 2, Svelte 3 and 4, and then Svelte 5. So they've had basically 3 versions of Svelte over their first 7 years, which is good because, like, in a sense, when you change and you increment, you learn stuff and you move on. In a sense, Solid hasn't changed since 2018-ish. I mean, 2019, I guess, when I switched to the tuple thing. But even if you forget if you replace the array destructuring with like get or how did I used to do it? Yeah, it was like, I think it was .getting.set or something like that. Essentially, Solid had the same structure of app and the same technology approach since before I even released it on the server. Like, going back to, I guess, the biggest change is when I changed to JSX. So end of 2017. Solid hasn't really changed in a fundamental way in about 8 years. So, like, I don't know. It's interesting to me because we've been working at this thing and everyone wants stability. Everyone's like, oh, blah, 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 and ecosystem and all this stuff. I mean, I'm also saying this knowing that there will be a couple breaking changes coming in 2.0, but like, from that perspective, while continuing to push the boundaries, we've done all the right things in terms of being stable for our users. Like, to a point that there should be no expectation for us to be even stable even longer necessarily, because in the same period of time, every other framework has switched what they've done like 3 times. And I was trying to like think why this happened, right? Instead, like, Ricky was like, do you think it was prior art? Do you think you like, when you looked at other solutions, that helped you avoid stuff? And yes, I spent a lot of time looking at other solutions, but it's not even the solutions that they've created, it's the solutions that they could create. And I feel like it's because focused early on mechanics, looked at the best way to solve a problem, and then interpolated back, right? Sure, it isn't an approach without faults. Made plenty of mistakes, and there's a lot of things about 1.0 I don't like. We just avoided some fundamental ones by curbing ambition and focusing on engineering less on the developer, right? It wasn't like just chasing like, oh, what's the least number of characters you can type here? It was like, what's the best way to do this? And then let's figure that out, right? Because if you start from a place of performance first, you can usually find a way back to something acceptable, hopefully. But if you start from a place of like what you would like to write first and then kind of get there, you can't always make the performance. The shape of the API can actually limit what you can do. Hey, Shai, it's been a long time. Although it does require a certain amount of success to recognize it's impacting your mistakes. So we might be seeing benefits from lower adoption. But yeah, I'm just, it was just something interesting. I wonder if, something about Solid is innately characterized by these characteristics, and that's something that we can actually codify into like our values to make, Solid the type of framework it is. Like, sorry, I didn't even talk about Angular here in terms of change, right? Angular 1 to Angular 2. The switch to Ivy, which was a completely engine change overhaul. I mean, these things happen over time. Not, Solid being later to the game does have a bit of benefit, but when it's been longer now since Solid was introduced than like the time period of all the churn of the frameworks that people talk about. So this whole like, yeah, it's very difficult to look at the argument against stability, and like it becomes increasingly difficult to make the type of arguments people have been making against us as time goes on. It's just they look very out of place, which is why maybe that's why the growth with no releases, the growth has been doing so well. It's just like maybe eventually you get like hit over the head with a sledgehammer enough times, you kind of go, okay, fine, I'll wake up, I'll take a look. Oh, you're right, I did. When did I remove my screen? That's funny. Ten minutes ago. Did I not have it like the whole This Week in JavaScript? Okay, just before I started reading this thread. Okay. Yeah. The truth of the matter is things do have to change. I'm like the first person to say like if you find a better way to do things, change. Like this is the most ironic thing about this. I am not adverse to change. When React pushes these boundaries, changing things, I respect them incredibly for finding ways to do that when they're the incumbent. Like I'm the first person to push for change, and yet somehow we've just managed to be in the right spot. I don't think we'll forever be in the right spot. I think things do change. We somehow managed to find like, I don't know, is that what people call it when you're like 5 or 7 years ahead of your time? Like we just found the pocket, and now things are finally catching up to where we were 7 years ago. So it's easy for me. This is probably one of the last times I get to make this kind of statement. Do you know what I mean? Because stuff will continue to grow. We just happen to be, ahead of the curve in such a significant way, but like also not like appreciated or noticed for it. So like because we didn't have the adoption, it like perception. That's to say, how much of this what I'm talking about is just perception, right? And luck, because like how likely are you to come up with a solution that everyone else ends up doing? I don't know. Like, and then at the same time don't get adopted on your own merit yourself as much. Like we now have much more popular solutions taking the approach that we were doing 7 years ago. You know what I mean? Like, or 8 years ago. So it's like it's kind of funny. break the API, you break the existing apps project, and you never break user space. Do anything else you do announce here. So yeah, this is the thing is like there's a difference between say breaking changes and like React has done, for example, a very good job of not breaking. But to be fair, I guess I don't know how Vue and Svelte have done. I guess Svelte you can still use Svelte for components, but when they moved to Svelte 3 from 1 or 2, I don't know. Like you can be non-breaking but still change everything, which effectively been breaking. I think this is one of the challenges with the UI frameworks. Is like if you so drastically change the way you actually use them, you can be non-breaking, but yet at the same time completely change like how anyone would write it, to the point that the old code is basically not maintainable anymore because no one even knows how it works. So it's Python. I mean, sometimes those changes are necessary, right? And as frameworks and tools mature, they should be changing less. I mean, the truth of the matter is, Solid hasn't done 2.0. Like we have like Vue had 2 to 3, Svelte had 2 to 3, and again maybe 4 to 5. We haven't had 2.0, so I recognize that. It's just if you look at something for 7 years and go, yeah, actually 95% of it was actually the right call. I mean, that's a pretty decent place to be in, like over a 7-year period. But yeah, it's just funny because like you'd hope something like this, you know, I'm not saying this, I agree completely, but you'd hope something like this would help, you know, encourage people to, you know, do something. And it's like over the exact same time period, you know, yeah, people have switched with their favorite tool like 3 different times, you know, how they write stuff, to now the point that they're basically writing the same way they'd write in Solid. But they wouldn't just have changed to Solid in the first place like 5 years earlier. There's a bit of irony in it, but it is what it is. Yeah, I mean, most frameworks have been good on a migration path. I'm just saying, like, conceptually, it's still churn if you effectively end up having to rewrite all your components. Like, I don't like. Yeah, it was just something I noticed. It was, I mean, this is just like one of those hindsight things because like you watch where you sit there, like I can still remember sitting back to where I was when I was first like doing Solid by myself, like 2016 15 16 period, playing with stuff, and how I looked at the ecosystem, and then how I built the thing, and then compare it to like now, you know, like as I said, almost 10 years later, and just like it's kind of unreal to see this kind of change or switch over, and you're just like, huh. Makes you wonder how things could have been different. I don't know. Anyway, that's enough Solid stuff today. What else do we got here? Okay, yeah. This is good. I forget why I wanted to do this. This is probably subtweeting something that Ryan Florence said, but I probably don't have it anywhere. Maybe someone else's. Okay. Suspense activity and other boundaries are fundamentally different than concurrent transitions. Boundaries are read-centric and local. They care if and when something can be rendered. Transitions are write-centric and global. They enable transactional state updates. I'm kind of stepping back from the whole transactional thing, but it makes it easy for people to understand. The reason the lines blur is that while transitions wrap from the right, the indicator of completion is still based on read. So the state of boundaries can impact their completion. However, they aren't interchangeable and cannot be completely replaced by each other. Yeah, this is still talking about people trying to remove transitions. I think our whole stream today basically covered why this is the case. So I'm not worried too much about this. All right. This Ryan Florence tweet. Seems like if we went all in on canvas rendering, the web would be so much better. It's a clean start with the HTML DOM being requiring a whole new platform. And it's not fundamentally impossible to make canvas accessible if everyone is on board with it. And I think people misunderstood my quote tweet here. This kind of thinking I can respect. I can't comment on viability, but which I want to stress I can't comment on viability. I'm not saying that this is a good idea. I'm saying you have to challenge the assumption if you want to enact real change. We tend to not get to significant places by incrementing alone. You have to throw something out, move a step backwards and move forward. And I actually think that the Remix guys are one of the best teams or groups of people at doing this. I've been critical of them times saying that they move 2 steps backwards, 1 step forward, not 1 step backwards, 2 steps forward. But to be able to move 2 steps backwards still requires and understand how to pivot like that to be able to move forward again is a skill in terms of itself. This is a legit argument, and I was actually kind of laughing about it because this was actually my reply to. This takes not being afraid of where the train of thought leads you. Come up with an outrageous position and then try to take it to the extent. That's why we have the VDOM today. Not all ideas at work are worth it, but I'm glad to see the thinking get here. And what I mean by that is if Jordan Walk hadn't come up with an idea that conceptually was kind of crazy, like basically the virtual DOM, if you think about it, is a terrible idea. Like you're just like, why would you just do something worse, right? And yet it's worked so well for people over the years. It wouldn't happen if people weren't willing to challenge and go, I wonder if this is good enough or if this will work. And it was funny because Ryan Florence did this thing. Components are awesome, but not enough. Hooks and compose are awkward. Signals are this tweet. I read it and I was just like, this is kind of crazy, right? What if we didn't try something? What if better stupid? Like, I don't think. I mean, he asked some good questions, but I don't think there's actually an answer for this that's reasonable. So but I'm like, okay, let's think through this. And by the end, I was like, basic DOM is execution context unless you're talking about rendering to canvas. That's pretty interesting. Basically, if you follow the logic, you might get to a place that you don't expect. Because basically, to solve the reason we have these problems is because of the shape of the DOM. Otherwise, you can probably come up with a solution that will make some other trade-off, maybe in performance or something, and be happy without these, but you're not going to have one as good, right? And it makes it interesting, right? Because like every framework or tool has its own kind of angle. And in the case of SolidGiz, no, I initially and continue with the team focus on mechanics, on performance, on like architectural considerations. So when I see these lists and I'm like, yeah, this stuff's all necessary, to be able to kind of, because of the performance stuff, to be able to throw it out and start again takes incredible amount of like pulling it back, which is what I was trying to get at. Like I don't know. Everyone in the comments was like, this doesn't work. We tried this before, it failed. Okay. Yeah, I'm not commenting on viability, but it takes being bold sometimes to be able to change things up. And most of the time it's not going to work. Like 99% of the time it's not going to work. But that 1% doesn't happen if no one doesn't do this. Yeah, well, I mean, yeah, actually, sorry, Deb, I like this argument here because if you change your state, like the portability of your state actually matters like a bit on signals versus not, like once you have signals and you want to use signals in other components, and technically you can use them in your SOL4 components, but once you start translating your state into the state manager, then you have to go update those components, at which point you probably should change them to use fine-grained rendering rather than SOL4 rendering. So it's like, this has cascading effects because not every part of your app is independent, especially when it's about data dependencies and stuff. It actually changes the patterns considerably. I think the same thing is going to be true of Vue Vapor for the fine-grained rendering. Like that one's a little bit more isolated, but like these are big changes that, it's hard to know until you like get in there, and it's always the hardest part. Yeah. It's funny how standard almost nobody questions it. Yeah. I forgot people came up with a legitimate, like you have to, like sometimes it just works, like sometimes you just hit the right thing, Anyways, yeah, still waiting on this. Super stoked for the Veet documentary. Oh god, I forgot how much cool stuff I have here. God, we went through a lot the last few weeks, eh? Um, sorry, this one's solid. Am I on my page? Yeah, I'm on my page. I'm like, where's my bookmarks? One of these has got to be bookmarks. Oh, here it is. Yeah. Yeah. I mean, I coined JavaScript fatigue. Sorry, I just bookmarked this because I needed to see the guy who coined JavaScript fatigue, if this is actually true. Because this is the most. It's true, but it's also been like my biggest enemy for like 8 years. Um, oh man, there's so much good stuff here that I've missed. Yeah, I mean, I don't believe I remember reading the original article 2016, 15, yeah. Yeah. Yeah, and it's funny. It was it was relating to React change anything. Yeah. Here's your assignment. Yeah. Oh man, this is a classic. Thanks for sharing that, Dev. I was trying to find this the other day. Oh man. Sorry, I know I didn't put that on screen. That's fine. I mean, I could put it on screen for people who want to see it, but the article itself isn't very long. It's just like it's like a conversation. It looks like some of the old images are gone, probably because the React core team decided to delete all their posts on Twitter. So they don't realize the impact of that. It's fine. I'm still choked about that. I know it seems dumb, but like these social conversations become a fixture of like the history of these tools in the internet, and it just to remove them is just anyway. Where do we want to consider thing? Like there's so many different ways to go. I guess I just pick one. We're done with solid. So solid. Am I done with solid? Yeah, solid. Done with solid. Okay. All right. Angular has been working on deep signals, like apparently. I don't think I want to look at the code here. I think what I wanted to do was see people talking about the proposals, because I think someone like Manfred was talking about like how stoked he was about about the approach they're taking. Because they're using something kind of more path based than the way that we're doing with the nodes with the stores. The danger here, I think, yeah, they have almost like lenses. I wonder if I could find the API for it. It'd be easier to talk about it. I think the challenge here is you want to make sure when you have deep stuff that every time someone reads that property, it is done in the deep way. Because if you split between the deep and the non-deep approach, you're going to end up with weird UI tearing, which I think is my biggest fear of this approach, of just basically kind of like having these kind of lens like wrappers into the state. Because if you can access the same values without them tracking deep and also with them tracking deep, you end up in a weird like duality place where stuff can get out of sync with each other. Essentially, because some things will trigger updates and other things won't. When something changes deep, it should always trigger the update of the thing above it. In certain scenarios, there's places like when you have storage where you go, I want to trigger the deep thing. I don't need to notify the top level thing. But if you can listen to the top level thing, then you expect to get have the latest value and actually have it trigger. Like it's kind of like on you. I'm gonna have to see more of this in motion, but what I saw so far did leave me a little bit concerned. Um, I think I get it, but I it is definitely a different direction. Um, talk about those. Yeah, talk about those. Okay, let's go back here. Okay, this one's just a novel one I want to throw out here. I was talking proxies. I've been looking at for hydration, which is kind of cool. Are they just from Mother Zero? Sorry about the Angular thing. We all had to reinvent it. Vue, reactive, solid store are basically the same thing. The API services are a little bit different. But yes, we all need deep reactivity. It's a whole classification, I think, that's underexplored, especially on the drive side. That's why I've been focusing the last few streams on this. But yeah, there's a lot of devils in the details, and I do think there might be like a generalized solution of what these should look like. The trickiest part is as you move further away from the core of this stuff, it's easier to diverge and have different opinions and just like different types of solutions. I do wonder though if there's some fundamental truths here to be understood. Anyways, sorry, this example was fun. I was sitting there and I was like, I wonder if we can like create because with hydration, we could create an element before an element exists with this like idea I had using a proxy. So someone had a proposal for Solid for like create safe ref, which didn't really fit Solid semantics, but I looked at it and I was like, because they were like basically making almost like special helpers that would wrap like a function that would trigger when the signal and the ref updated. And I got what they're doing. I've seen stuff like almost like solid hook forms and stuff like that use a similar kind of almost approach to handling the internal refs. But then I was like, well, what if we just fake it? Like create a proxy ahead of time for something that we're going to set down here. But until then, we can, add an event listener to it, set a value on it, console log a value on it. This return a promise thing is kind of interesting. I'm not sure this is the approach but basically I didn't make this. Mizulu or Zulu on our Discord like basically heard me think out loud and then just made this demo, and it just looks cool to basically be able to wire the stuff up before it even goes. And because solid components don't rerun again, this is perfectly valid way to do stuff. You basically are just setting a bunch of stuff on the proxy, which you store. And then when the actual mount hook happens, like when it mounts with suspense or whatever, whenever it happens, or show, he's using show to show the timing coming in. It's only at that point that it actually can resolve and sort all this stuff out. And cool, that's all I got to say about it. I don't know if I'd go all as far as doing this, but this is the kind of thinking that we have to do. When I talk about thinking about outside the box and trying to push stuff, it's like if the shape of the problem doesn't fit what you're doing, like rethink it. Like if refs are awkward, maybe create them ahead of time. Like the other thing reason I like this is there's no create effect here, right? Like I've been playing this kind of game of like how many ways we use create effect can we get rid of? Because on one side, I think I kind of tried to show, and I think it was actually kind of obvious today with the transition stuff, why effects need to be split to actually do what we want. Like they kind of have to be. But then it's like, can we avoid using create effect? Like, is it just like our effects, should they be for something very specific, like for side effects of your system? They definitely should be for syncing safe state. Maybe you don't even need them for managing DOM refs. Like maybe there's a better way that effects are literally for stuff like logging. You know what I mean? Like, we know that we don't need them for async. We know we don't need them for, a bunch of other things. So interesting, nonetheless. I'll paste this example in case anyone wants to look at it later. Okay, just double checking something here because we talked about all of this stuff. Okay, yeah. So my last technical topic is about the browser. Before we get to that, let's look here. Let's talk about React for a moment. It looks like React, the good parts: components, composable building blocks, or UI. JSX markup uses JS language extensions instead of bespoke template language. Virtual DOM, render everything, let the runtime figure out. I don't know if that's a good thing, but let's say it is. REST, sometimes you need input.focus. The okay part. See, I view this as like the good, the bad, and the ugly. Because he calls them okay, but context, synthetic events, okay, that's fine. These are actually okay. The style prop. Yeah, I guess it's a special case. Class component lifecycle methods, mostly deprecated now. Yeah. Effects, workable but foot gunny. Bad parts. React owns your states, re-enters coupled to state changes. Okay. But that is the virtual DOM. I mean, unless you want your users to call update themselves, that is the virtual DOM. Or you're like doing some kind of polling system. Lines are blurry around what state is versus refs. I agree. That's because of the virtual DOM, again, because of re-renders. Rules of hooks or rules. Yeah, how is the virtual DOM not the bad part here? Like all his bad parts are an extension. Like, okay, fine. You don't need hooks if you have the virtual DOM. Like the virtual DOM doesn't mean you need hooks. So like the VDOM maybe is in the okay part and the hooks are the bad part. Bundle match rather full set modern feature. I mean, it's server rendering. Yeah, I mean, it's tricky. I feel like SSR is the main reason for this, and there just isn't isomorphism is actually the main call for it. Like you don't avoid this. It's not like remix isn't bundler magic either, right? Like having magic exports is definitely bundler, like loader and action is definitely bundler magic. So I don't know. I feel like bundler magic is like the okay part. It's like a necessary evil. Like I think everyone recognizes that at this point. But I do think this is an interesting way to break it up. Because components are great. I think JSX is great. You don't need refs if you don't have the virtual DOM arguably, but yeah, refs are pretty. They're okay. They're pretty good. I think if refs might actually be okay. Context is kind of interesting because I think context in fine-grained systems is a good part, whereas in React it's a mediocre part because you can actually put state in it and like all your third-party state solutions can work with it. Like you can't use state in context without like it kind of, you have to bring your own management in, but in like a signals library you can. Synthetic birds merging user predicates ugly. I agree, but yeah, this is definitely on the side. Style prop, yeah. So yeah, I don't know. Class components, right? As I said, they're not gone, but they are basically. So yeah, I think that's an interesting list nonetheless. I do think it's funny how many of these things are related to the virtual DOM though. Let's see another one. Functional programming is absolutely correct. Logical way to write code. It was discovered like physics rather than invented like social science. Yes, which is a good characteristic to have. However, only people with socially ability can master it. Best needs social science. That's not a fact. Or what's a monad? Or effect. Yeah, he's like, I remember introducing use effect on the world stage. Purity over pragmatism, and then try to force on other languages. You don't need to really intellect to master Erlang, like Suro, Camel. Like this is all positioning stuff, I think, for the walk away from React. But I like the engagement they're getting on this. It's interesting. What else we got here? I'll get back to that one. Hi, I have thoughts. The short answer is app router is easy but not simple. It's easy to get started, but complexity ramps up fast. I've said this previously that if you don't need streaming, then the app router might not be a good fit. Why is the site slower on the app router? Okay, let's see. I've wondered. I flagged this one because Lee doesn't work at Vercel anymore. But he still decided to kind of talk about like the trade-offs here, and app routers apps have hit some impact. I wonder what his perspective is. You know, maybe it's slightly different now that he's not there. Here's some random complexity ramps. What React transitions are and how Next.Router uses them. Okay. We talked about transitions today. How streaming rendering works and why Next.js apps are designed to word them, like generate metadata. Right. Okay. Because it's tricky because you have to hoist the. Yeah. Okay. Like the data fetching, the hoisting, and the timing is tricky in order to get streaming to work in the right way. I see what he means now. How dynamic rendering affects different prefetching configurations. Yeah, yeah, yeah. I do think PPR and stuff add this extra layer that makes it even more confusing. What RC play and how to optimize it. Why server actions are unguessable and encrypted URL endpoints. I don't think that's a big deal, but yes, it's a good point. Why use client is actually a bundler feature. It is, yeah. It has to be. This is kind of something we talked about. But bundlers are actually kind of essential, which is what Ryan Lawrence's or Mike MJ's, I can't forget which one of them complaint was, but we're getting kind of to this point where like you can't solve this just with a compiler. That reading search params, because like you might not, if you have code splitting involved, sorry, just to clarify, you might not pull, like things have to exist on the client and the server builds from a whole graph understanding perspective, not just like as you hit them. So it takes more than just changing the code, because you also need to have the code that registers the code that and links it back together. Reading search round takes your page dynamically rendered. Yeah, I guess that magic stuff. Most of this complexity comes around is that the app router is designed almost to start from like I'm building an Astro site and then scale up from there. Explain where the essential complexity, step back and ask yourself whether Next is the right tool for the job. Many times the answer will be yes, how I'm building Next app router, but other times it's no. Next is with Army knife. Sometimes you need the really sharp single purpose knife. Yeah, that's tricky. That seems tricky. But yeah, I don't know if I actually have as many thoughts as I had. I just marked this because I thought it would be interesting to see what he thought. But yeah, I mean, takeaways, sometimes it's tricky to have an easy to use but general tool. You know, when you make stuff flexible, it's different than making something adaptable. It's one thing, like you can keep things simple and you be able to use them a lot of different ways, which I consider being adaptable, where being flexible is usually involves like having config or having like lots of different modes something can work in. But hides that, basically hides the complexity from you. It makes it easier, but it doesn't, make it simpler. I bookmarked both of those. We'll get back to that in a minute. Actually, you know what? Let's talk about it now. We've been talking about a lot of Ryan Michael stuff because it's interesting. Sorry, it's funny because I said I probably wouldn't talk about the stuff on stream, but when you're building a framework, you end up in these weird zones where you're like, can I do this thing a little bit differently? And I relate to a lot of the tweets when I see them. Whether I agree or disagree is a whole other thing, but I actually see a lot of these tweets and I'm like, huh. But yeah, this is a funny thing on AI. Ryan and I are barely writing any code ourselves for Remix Tree. It will be the first web framework that is almost entirely written by AI. I read this and I was just like, this is batshit crazy. I can't picture it, but maybe I'm not that AI versed as you guys saw in the last stream. It's interesting. And I started like asking myself a more general question: would I trust an AI to write my framework? And I mean, the answer is no, because like generally my experience with AI is it caters to the lowest common denominator, which means you never get the best thing. You always get the reasonable thing. I think when they say it's written by AI, it's like the previous version was written by VS Code. Oh, okay. Let's see what. It's interesting. Maybe like if I was doing like solid star stuff, I could see this because like I don't write my like you can actually almost see this like in the repo. I don't need to turn through a bunch of code when I'm most of the time when I'm working on solid. Like the signals thing is like less like when I put the build output out, it's less than 2,000 lines of code, right? And I've been iterating on it for like a year. Like um I'm not doing a vast amount of code. I don't need to like churn through this stuff. Every decision is so critical. Every piece requires like weeks of thought, right? In terms of how they all work together. Like I'm not being bottlenecked by my ability to code fast. I'm being bottlenecked by my ability to work to think through problems and finding solution. Right. I mean, there's a different thing about AI failing to, to work with not being great with, certain types of things. Or unless you're saying, okay, it's something else about AI working on libraries. Like, do you mean like using AI to work on libraries, or AI not being good at generating code for certain libraries? Yeah, it seems to fail with libraries specifically. Yeah, I'm more talking about like picture you like I'm writing my like solid signals, yes, signals, and I'm working on this code base with AI. It's like I just can't. As I said, I'm never limited by my this pretty much ever by my speed to code. It's not even generally by my speed to implement like ideas. It's more of like you implement it and then you go, oh, this was the wrong idea, and then you're like, okay, I gotta like do this again or refactor this out. Like so, it's like I I when I read this, I'm just like, what are they building that this would actually have any kind of impact? Like any. Like I was like thinking like there is a it's not like you build a lot of features and that require a bunch of code. Like when you're building product and you like you have a new section of the app and you're like, okay, crap, I need admin sections. I need to manage that. I need like all the features. I need this view, this, like I got a light box here. I got like modal pop-ups. This can flow, maybe a wizard, simple view, expert view, like there's all these kind of considerations when you go like, I'm adding this feature to my product. Frameworks, generally, the pieces are much smaller and they're all integrated. So like, I don't end up when I add a new feature, I rarely ever, I end up adding like one function and then editing a dozen other functions in different places, like a one liner here, there, and then sometimes goes, oh, actually, I can't do that, and then like pull this thing out or something. But it's not like the amount of code that changes is so minimal comparatively. Docs, yeah, I can see that. The critical part is code. You're definitely not going to write with a code. You're going to make it persist updates or use completion. But like everything, I feel like everything I do is critical. I don't. Maybe I'm just view myself too self-important. Yes, yeah, tests. God, AI and tests have been my best friend. But I won't. You know what I mean? Tests are amazing. Really, we first read that's written by AI. Yeah, I don't know what that means. Maybe they're just sensationalizing. See, I can see that maybe for 10 stack DB. I could see that for like, yeah, I don't know. Maybe I just lack the way to, yeah, I don't know. I couldn't even describe what I was trying to do. I mean, maybe I'm just not seeing this well enough. I keep feeding elements examples from another framework and then rewrite and remix tree. Then I ask it to compare and contrast to determine which is easier for devs elements to create bug fix and change over time. Maybe it's glazing me, but I get this kind of response every time. If you want a quick sanity check, give a mid-tier LM 2 tasks on each version, blah, 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 blah. So not flattering. My take is that reducing invisible links and specialized lore that tends to win for approachability and safe edits today. I mean, reading this, so you usually see fewer mistakes and less back and forth on the remix variant because the edit points are obvious and the behavior isn't hidden in the dependency graph. This is interesting because I can get this perspective. He didn't ask it which produces the best results. He didn't ask it what's the most performant. He didn't ask it what will give the best user experience. He asked which one is more likely to, produce the working results to the expectation of the framework, right? So like, we talk about lowest common denominator. Like, can I make my framework dumb enough that anyone, including an LLM, could leverage? And I think this is an interesting quality because this is their pitch, right? This is their thought. They're like, I want to make a framework that works really, really well with LLMs. What does that mean? Well, it means that you can ask it something and it generates the code that works, for it. React is pretty good, but we want to make something better. It says nothing about the quality of what comes out of the other side, right? Like, you could build something that the AI can generate no problem. I mean, this is an interesting hypothesis. If it performed good enough but you could just, easily generate it, this would be an angle because people won't care if it's not the fastest, or like picture a framework that was like React but slower, but it was easier for LLMs to generate. People would probably still use it, right? I mean, you would hope over time that AI would just choose better solutions, or that you could like build better stuff with it. But if you're targeting the lowest common denominator, like if your goal isn't to over time create the best thing, but approach the thing to where it's at today. Actually, you know what it says here? This tends to win for approachability and safe edits, comma, today. The AI said today. It even recognizes this might not be the case in the future. But if your goal is to approach what happens today and close that gap, then this makes a lot of sense, right? Right? Like, I remember the Devin creating the To-Do MVC app that used what I forget what component library is a really big one, but it basically they created like a 300 kilobyte to do MVC app in React and a bunch of stuff and used all the libraries and stuff. I think if you're okay with that and you can create more like better like things that more represent what you're trying to create, like if it's better at creating what you visualize on screen, there's a lot of people that would like say take a 2 megabyte bundle size for that, you know. Like I'm not saying that you're doomed to fall that way, but I'm just using that as an example, right? Yeah, I mean a little bit, right? Like it's definitely setting the bar pretty low in some ways, but on the other hand, yeah, it's approaching what happens today. Oh, that's an idea. Give AI all my hack MDs. So I'm just looking at the comments here. Catching up on. Oh, sorry, the Rich Harris thing. Okay, yeah, we'll talk about that in a second. I'll finish up on this one here. AI is fine for CRUD and boilerplate. Funnily enough, Solid will always be better with LLMs than whatever Remix 3 comes out with because Solid has more training presence. I mean, I don't know if that'll always be the case. I mean, I hate when React levels that argument against us, but you wonder if this is a situation where if you're trying to rush approach where things are today and it's a moving target, and for that reason you miss. But yeah, I agree. Simple and readable code is preferable, but I disagree. Can write simple that works. That is bug free. Yeah, yeah. This is kind of an interesting question. Call it equals here. I love these questions. The main thing to understand about AI is they're going to be as good as the prompts we give them. Yeah. So I mean, that also makes the challenge. But the thing is, the idea is they want to make the prompts like get better at handling the prompts, right? That's essentially the goal here. It's like attacking it from the other vector. I think it's interesting. I just don't know if the result is worth chasing, but like long term, but short term, this might be an angle, right? Is Solid.js stagnating, or is there a future from 2008 watching how things are going? I mean, I feel like if you've watched any of the streams, then you know that, like, I mean, even this stream kind of covered everything, right? From the growth that's happening, the 2.0 changes and features, the how Solid itself core hasn't changed very much, yet has participated in, and led in a lot of the innovation that's happened in front end in the last 7 or 8 years. So yeah, I mean, we haven't stagnated. Just certain areas. We focused on other areas other than the core reactivity, I'd say, and because we had that mostly right. But yeah, I mean, this is interesting. I really do like opening this kind of thing. Okay, but he just links to the thing about how all this stuff is awkward. Yeah, I mean, it is awkward if your goal. It's interesting. Like, is the goal to make it as easy as possible to accomplish? I mean, obviously, the goal on a high level is to make it easy as possible to accomplish your goals, right? Like that's the goal high level. But there's a lot of like quality questions that come in between. This is very interesting because this is like the exact opposite way I look at the problem space, which is interesting to me because it starts opening up, the potential of thinking about this. Huh. Honestly, yeah, really interesting stuff. Okay, let's see Rich Harris. This is an interesting balanced research and it confirms my priors that I'm sharing it. It also makes sense. LLMs speed up your typing part, which feels like the bulk of the job, but it's actually dwarfed by the thinking part, and these things don't think good. Randomized controlled trial to see how much AI coding tools speed up experienced open source developers. The results surprised developers thought they were 20% faster with the AI tools, but they're actually 19% slower when they had access to AI than when they didn't. Also, participants are OSS devs, library authors, people largely building kind of software that doesn't already exist in training data. If you're building a product app or marketing page, maybe the results are different. But what the study doesn't appear to account for is the time spent weeks later when you're trying to augment or fix code that no one on your team wrote. Me vibe coding. Yes. Me vibe debugging. Yeah. Yeah. I just like, I literally, like, this is the exact counterbalance. This makes sense to me. Whereas this just seems like craziness, but it's sensational. So I don't know. You're you're either wondering, like, are they just building something like are they building something massive? Like, is this like, are they building Rails? Like, are they building something where they just have so many features that they just need to spit them out, and like typing actually is a consideration? Like, they're just like, we have like this huge feature set, we encompass everything, and that would make a lot of sense. Because like I'm here, like that's interesting. Okay. Okay, so that's it for bookmarks, I think. Okay, yeah, there's one more, but I mean, it's already here. It's for Dominic Ganaway, creator of Inferno, Lexical, main catalyst probably in Svelte runes, and the upgrade to Svelte 5 and fine grained reactivity. An all around great guy. We've had him on stream before. I know we talked about this like previous stream, but it's official now. He's leaving Vercel, and he's also hasn't been working on the Svelte team for a couple months now, as we know. So this is the big change, right? The Svelte 5 journey was especially incredible. It was challenging in many ways, but I truly feel the web is a better place because of what we built with Svelte and Svelte Kit. The team behind it is such a talented and friendly group of people. I miss working together. Yeah, but big shift. Yeah, Dominic is not with the Svelte team anymore. He hasn't said what he's doing yet, I believe, but in my world, at least, this is big news. Of course, I've known about it for a little while, but it's official now. So, yeah. As I said, I like it's kind of funny because I remember I was talking. Dominic was working on some of his own prototypes of signals and trying to create this community reacting that signals can be used under the hood, and then he wasn't finding the right place for his work. And then he actually talked to Rich, and they actually like, okay, let's do this. But if Dominic hadn't done that, I wonder if Svelte 5 would exist in the form that it does today. I'm not sure. It's definitely interesting to see the kind of impact people coming and going out of projects can have on those projects. So yeah. Very interested to see what he does next. Okay, I think that's it for bookmarks. I think I have one more topic, probably about, I don't even want to talk about that. Probably about web components. Yeah, here we go. Okay, let's do it. The dividing point between frameworks versus platform purists is the belief of whether DOM should be the source of truth for state. Almost every web component argument issue with design comes back to this. You don't need to go any further than forums to see this in action. The gap between the value attribute, the default value, and the value property already surfaces this tension. When UI equals a function state, there are fewer concepts than even using native APIs. However, using both together correctly ends up being the most involved and easiest to miss certain edge cases. You can see it even with the increment and reset buttons. To be fair, Solid, like most frameworks, already use special cases value as a property unless it is static. And the reason this came about was it's so awesome now to be working with the teams of people. Like, I know I often get credited with a lot of the work on Solid, but we've actually kind of split stuff off into, there's certain people working on fellowships in specific areas, certain people in the core team who have specific specialties, obviously you guys see a lot of the work I do or dev does more than anything else, because we talk a lot about async models, we talk about events, we talk about concurrency, have expertise in this area. But there's other people on the team who do amazing work. And one of our fellowships, I think it's Tito, hopefully I'm pronouncing the name correctly, has been basically taking over DOM expressions in the compiler the last 6 months or so. He was instrumental in the changes in 1.9. So yeah, whenever that was, the web component changes, I guess it's been long, maybe almost a year. And he's been a huge force in updating and standardizing the stuff for 2.0, mostly because he's also a web component guy. And he knew my frustration with dealing with all the edge cases and web components. So he's been looking at the community going, okay, guys, how do we actually do this in a way that's good for web components? How do we make this work in a sensible way? And he managed to come up with a solution that's quite agreeable to me for the most part. He's like, let's get rit of setting properties, default everything to attributes, even on web components, which I always thought was weird. I wanted props on web components, lit, make things explicit. And all the details of this have been actually great. He also triggered the web components are not the future article, because I was just so frustrated hearing about it. The funny thing is, after that article broke, and he's still a web component guy, don't get me wrong, but after that article broke and he was in there trying to defend, and then he heard the back and forth and he actually worked through the problems and been working DOM expressions, I think his perspective is changed a little bit. Like, he's still, into this stuff, and he understands what the right solutions are. But I saw him get into arguments even with the web component people, being like, you guys are just being kind of crazy. They basically didn't self-identify him in the they were like, oh, you're just a Solid guy. But ironically, his impact has actually been fairly substantial. Because if I go here, there is one more story that I missed here. I want to talk about our man Tito here. If I go to my profile, because I've got this blue sky only string. Justin from Lit went and was like, a while ago, there's a kerfuffle about web components. So he's talking about my article, basically. Frameworks were mad that they had the detective templates contain custom elements so they could switch between clone node and import node. This was one complaint out of dozens that I said I believe is actually a fundamental mismatch, which is what I'm talking about here. But he was saying, but it turns out import node was slower than clone node in Chrome. So frameworks added extra logic to look for elements with dashes in the name to choose import node only for templates to have them. And some blamed web components for messing up the web APIs. Fair enough. Some framework contributors filed bugs against specific new features like is custom out so that they could farm this detection logic to browsers, and got really mad when the browser said they shouldn't ever need that. I mean, that wasn't us. Because import node being slower is just a bug in Chrome. See, okay. It was kind of a silly situation, and some people in the web components community filed an issue in Blink and advocate for performance to be fixed. Turns out some kind of navigation heuristic tracking import node, not clone node. So the bug was just fixed. Now import node and clone node have the same performance in Chrome. I'm happy frameworks can get simpler, but also because Lit, which also uses import node, probably got faster too. Filing an issue for browser implement bugs is a good thing for everyone. Okay. Do you know what problem I have with this? How in the world are you supposed to know that this is a bug? Import node does do different stuff than clone node. Otherwise, we wouldn't, why should you even use it? He basically you should always be using import node. Why? I don't know why. But we know that clearly if clone node did what import node did, we wouldn't need import node, and we just continue to use clone node. Import node actually adds it to the current document, where clone node does not, which actually has impact on certain types of elements, custom elements, iframes, a bunch of other ones. But so it does more work. It's like saying, should inner HTML and inner text have different performance? Probably. Inner HTML has to parse from markup. Inner text knows that it's just text, right? In fact, text content is faster than inner text for another different reason. In fact, we hit these kind of things all the time when building a framework. Every little detail like this, and we don't question it and go, oh, we just go, okay, well, this seems faster in all the browsers, probably because it's doing less work, right? Simon H, you got this backward. This program was fixed only because Solid and Svelte were actively working around it. Look at the reproduction. It's referencing Solid Playground. Thank you. Tito actually created the issue. So just side note. I have no idea what you think is backwards, but you sound like a jerk with this tone. Have fun with that, I guess. Then Dom, I'll talk about Dominic. Yeah, I mean, we can look at this, but yeah, I mean, that's a very good thing. I don't think the complaint was silly. It's just difficult to know if something is fundamentally slow or if it's implementation. Fortunately, Tito, Solid Maintainer reported the issue. Now it's fixed. For everyone, for an issue like this, there's a dozen not so easy to address. Also this, yeah. So so Dom's like, your tone's off to start with. I and a bunch of other framework authors have been pushing for this change for a while and been pinging folks at Google as it gets escalated, even when I was on the React team. While you might think it's a silly situation, for those who really care about performance implications here, have strongly aligned that this is a Chrome bug that just needs fixing, as it's not evident in other browser engines. Furthermore, just filing issues is simply not enough. This took a lot of effort for folks to push the issue specifically, so it got noticed and had eyes on so many folks. Tone regarded this should have been different from the start. This was a community effort driven by framework authors who have wanted to address this issue for many years now. This work had nothing to do with web components or lit. That's why the tone is off. Silly issue. There's no issue filed against Chrome at all. The Chrome DOM folk I talked to didn't even know about the problem, so it wasn't widely known or probably even actionable for the DOM team for apparently years. It took urging web components Discord to get anyone to file the issue. Once it was done, there's a visible progress. It's silly that took years to file anyways, but you're welcome to blah, 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 blah. I was on this React team, we had early meetings, Chromium folks. Yeah, that's probably true. It got worse in Chrome 125. Yeah. A bunch of times you quick as I don't summarize it, join it. It's silly. Yeah. I mean, this is a tricky tension here because you can hear it in Justin's tone initially that, we were all just being silly. And yet, like, how do you possibly conclude that? I guess they don't know it's an issue unless someone reports it, but no one's going to report it. They'll just work around it. And unfortunately, no one, probably the real problem was no one knew why web components don't work with clone node in the first place. There's probably a really good reason for it. But like, essentially, this is kind of the realm here of the kind of challenges we come up here with here. And I want to show, I'm going to go back to my thing about DOM holding the state. Because the funny thing is web components encapsulate state in the DOM element, even if, they don't intend to. You're actually encoding that logic, not in, like, instead of having components that output DOM, essentially, you're actually encoding that information into the DOM elements themselves, which is, as I said, fun for things like SSR and serialization considerations when you're dealing with properties. You basically can't serialize props unless you do something specially, whereas attributes are the way. And because of, again, it makes sense there's a difference between attributes and properties, but having properties is only valuable in places that don't have HTML that have the DOM, right? Whereas attributes can be used in places that only have HTML. So there is this kind of tension here. And what I wanted to point out here is sometimes the model, let's open all three of these. Sometimes the model is easier without using the native stuff. Because here, for example, this is completely a naive framework approach. We're pushing state. We're like, okay, we have some state, you create signal, use state, doesn't matter what it is. increment it, reset it, driven by framework. So we update to 4 or 5, we hit reset, it goes back to 0 because we set it to 0. This is how people are introduced to this stuff these days because of React, right? It's simple. You drive it off state. The DOM is kind of like an output, right? Like we don't care. It just, we control the state. Now, the naive DOM approach is kind of interesting. I love value as a number as a side note. If you guys aren't aware, it lets you, it basically converts it to a number. Now, the simple framework version should have also had type number. I missed that. But because it lets you do this too, because you'll see why this is relevant. Because this is you setting it via state, right? This is typing into it, essentially. Am I missing something here? Yeah, sorry, you know what I'm missing here? The naive framework, I don't know how did I miss this? Sorry, this is my bad. This is actually my bad. The naive framework version should have had event. This is my bad. Event dot target dot value. Okay, sorry. I don't know how I missed that. That actually probably makes this look way. Okay, now we're better. So this goes up. This. All right. Cast it. Yeah. There we go. Naive framework version. I actually missed that. That is actually on me. Now the state's unified. We reset. Okay. Cool. Okay. No problem. Okay. The naive DOM version actually in a lot of ways is a little bit simpler because it stores the state inside. So when I press plus, what I'm doing here is I'm updating the DOM node directly. And then when I press this, my input is updating. And then when I call reset, I'm actually calling the forms. There's a type reset. I don't know if people know this, but forms also have a type reset, which automatically resets it. So now the state is owned completely by the DOM in this example. So here we have, external state driving it. Here we have the DOM doing it. And arguably, the benefit of this is you don't need event. You only need the event handler on the increment to synchronize. But you did have to know about a button type reset to make it work. But I mean, I think this is reasonable other than it doesn't scale greatly because it's like you can't pull the state out into something else. And then the final version is, and I'm actually missing something here. I just realized. I need to add this. The final version that handles things properly is this version. See if this works. Yeah. Then reset. Yeah. Okay, cool. And the way this one works is this is DOM correct because it's using the reset button. And the thing that isn't obvious here is this is setting the property because we do that by default in Solid. And this one is setting the attribute to make sure that it matches. Because if you didn't have the attribute, the reset wouldn't work because the input has to have the attribute of value is the default value. Technically, I could have also done props default value, but I'm just trying to kind of show that the attribute, like if you weren't overriding it, like made this prop value and make this just value, like if you're trying to inverse it, would have to be like this. And this handles like the full scenario here the proper way. Right. So the reason I'm trying to show this is like state driven, DOM driven, both. Both is definitely the most complicated, right? And the reason this is like a concern is that it's very easy to like not do this quite properly. Let me see if I, where is it? I'm not seeing it here. And I actually started asking people this because the argument was we should not special case it. Essentially, we should say value is just an attribute, not a property. Every like people say they want their framework to behave like plain HTML, yet every major framework except lit special cases value checked and selected as properties, since setting the attribute doesn't update the input, just sets the default for form reset. Right? I gotta admit, this vote was closer than I expected. I expected most people, like wide range. I expected this to be like a 90-10 vote, not like a 57-38. So that is actually interesting. But this is what I'm talking about. If if we use attribute to bind, when we reset, okay, that worked. I'm trying to remember the case. All right, this is not type number. So this will just make my life easier. Yeah, this is a fun one. Because we're binding to the attribute, when we click reset, it doesn't actually, we're changing the default value, not the actual value. So reset now doesn't work properly, which I mean, that's fine. But more importantly, the state got out of sync. Now, to be fair, I think I should add on input here because I missed this. But I'm just, the reason I'm going through this is I'm like, picture this is just how value worked by default. So when you did this, oh wait, plus doesn't work. Right? But make it more confusing. Plus works initially, but then once I change the value on the input, plus stops working. This would be the default behavior if we bound to attribute instead of to the property. This poll might have been shared on a web Discord or something. Maybe like it's kind of like, picture if this was the default. Like it's kind of crazy. You're like, okay, I'm setting the count. If you're like value and then you're like bound to value. Basically, I think if this is how solid worked by default, people would be like, what, how does this work? Because the proper answer is you tell the end user to use prop.value, right? Because then when you do this, oh, sorry, I gotta plus it again. Sorry. Because then it will work the way you expect it to. But just doing the value binding would essentially work like this. Stop working the second you actually change the input. I don't know. I think the reason it's weird is because the value attribute maps to the default attribute value prop, and the value prop doesn't have an attribute. Yeah, but I mean, every I was like, this is what I was trying to figure out. Like, people who actually think, like, who in their right mind wants to know that this is how it works? Like, this is way closer than I expected. Lit works like that. Not a single other framework works this way. But the reason we're forced into this is because of, as I said, weird stuff. Like, it's not weird. It makes sense why forums have, let's say, a reset button. But like, picture this one. Like, what if we just said, I mean, I guess we should have no expectation that state doesn't work. Yeah, I mean, I don't even know. This is just, I'm just breaking things at this point. I just like, considering the number of people who like choke on solid using on input instead of on change, I cannot picture the number of people who would choke on being like, on like, oh no, you have to use prop colon value instead of just value here. I like, but this is where things are at. I just kind of wanted to put this out here. Um, there's a bunch of other special cases like values. Like, if you have ranges on inputs, if you set the value before the range, the value doesn't come in like within the range. You have to actually set the ranges, like min and maxes, before you set the value. There's a bunch of special cases that we have to do around inputs anyways. Even before you get to this, we actually pull values out into their own separate binding. They don't get grouped. So like, this is already very like a bit magical to kind of compensate for like weird discrepancies in the DOM. I think this is an interesting touch point, though. As I said, like, this is kind of reflective of where this split is, and I don't know where people sit on this. I mean, clearly more people want to leverage their knowledge of the DOM here, but I can't picture the average developer wanting to like go, oh right, yes, I was setting the attribute. I need to actually use the value property. Now, I found out Vue gets around this a little bit because people use their model, and Angular, they tend to use the models which use property, and if you just use the value directly, it uses the attribute. But obviously we don't have anything like two-way binding, so we're not going to like default to attribute and then switch to property. In fact, Tito's own framework also uses like two-way binding, so most of the time people are using this other syntax, you know. But it seems interesting to me to like, you don't need to know about prop colon for anything else except now you do your first input field, and that's when you have to do it. I don't know. These are the kind of things that keep these communities divided over kind of silly stuff like this, because the framework authors resent having to special case, and even more so for web components. This one, see, we can special case this one because we know the input fields are weird. Like, we just know that. But picture random web component someone makes. We don't know which stuff's weird. That being said, I think in general, other than these special cases, the approach that we're taking in 2.0 of basically defaulting always to attributes unless explicit is probably the most sensible thing. It gets rid of a bunch of extra checks and all these weird, like most of the other weird special casing around web components. So, and another change that we're proposing for 2.0 is for Booleans to actually require like Boolean values if you want them to show or hide, right? Like the string, like there's a difference between a attribute that takes a true string and an attribute that's in a Boolean attribute that hides with false. I think that change in general will be good. We'll have to play with it and see what people think. But sorry, where am I? I think this. It's funny that we've been struggling with this stuff in the web development community for like 15 years now, and it's still, it's interesting that this stuff kind of comes back to head, because this is like in 2010 over special casing value was just the obvious choice, and now it's like, do you want to not special case it and push that responsibility onto your users just to be more consistent to consider, things like web components? 38% of people think so. So of pollers here think so. So I mean, I don't know. It's interesting. Well, because jQuery, because most people aren't thinking about stuff at this level. They just like bind up their stuff. Like, as I said, in a lot of ways, where's the original version? Yeah. This state-driven version is just the most straightforward implementation. Because like a lot of ways, this is the most straightforward actually, sort of pure DOM thing, but you know that this isn't going to scale with your data set. So the only thing that gets really weird is here, like, notice I actually have attribute value 0. I think it's because the default value with that absent, yeah, there's no default value. The reset button doesn't work properly. It sets the count. Huh. So I actually need to put the value on here so that it has something to reset to. So yeah, I mean, it's interesting. Like, you need to use both if you want to, yeah. Even though I'm handling the set, yeah, this is actually interesting because I'm handling the reset event. I wonder if I have to do this. Like, I wonder if the trick here is to do prevent default. And then I don't need it. E dot. I wouldn't say this is working exactly with the on though. Prevent default. Would this fix it? Yeah, there we go. Now I don't need the attribute. But at this point, it's like, why am I even using the reset event? I could literally just put on click on the button. Do you know what I mean? Yeah, the reason I had to do it as attribute here is because value equals 0. Solid actually does make it an attribute when it, like, there's nothing dynamic on it, I guess, which is an inconsistency. But we can't use it because we already have value bound to count. So I mean, that's the argument. It's like, how do you set a default? I guess the whole argument here is how do you, if you don't want to prevent default and you don't have attribute this, because one of the cool things about Tito's PR is that this attribute thing is gone. We don't have it anymore. We just have prop. In order to get this behavior so it doesn't collision, you'd have to do prop default value, I think. And then let's see if that works. Yeah, that works. Of course, you could also just prevent default in the reset. But if you want to use reset, the way the browser intended, you would do this. And honestly, I'm very tempted at this point that we should just support default value as a, like, if you're going to do value, then we have to support default value. I'd rather people go from value and then realize they need default value, I think, than for people to start realizing that they immediately need to do prop.value. And then, yeah, this stuff is just weird, right? Yeah, sorry, I noticed afterwards. I was just saying that, like, for this to work properly, you'd have to, because you have a collision with the value name, you'd have to do like this. We could also just get rid of the prop here for this. I don't believe the namespaces should be used for anything but special cases, which makes it difficult to say that value shouldn't be a prop, because If value is the attribute, what do you call the prop value without using a special case name? Yeah. Anyway, it's a topic. All right. I think that's it for me today. Other than, so what did you share, Fuzzy? Let me see. Can I use CSS attribute? Let me see. Not in Safari or Firefox. Huh. Oh, interesting. I hadn't seen this. Yeah, so it says here to use it for non-string values, including numbers and colors. That's cool. Anyway, I think that's it. The stream today. Yeah. How did we do? We did 5 hours, didn't we? Yeah, five and a half hours. Okay. Yeah, long one. Thanks for joining me. Again, like the video, or if you can, it definitely helps out. As I said, not streaming this Friday, but September 5th, I should be back. I believe Dylan Piercy from Marco will be joining me to talk about upcoming Marco, which is very exciting. So I've been looking forward to talking about Marco. So hope to see everyone there. You guys all have a great long weekend coming up, and till next time.